All right, so actually, I want to be down here. We are on our second stream of the day. I just got done with a little college class that I was running. And what we're going to do is we're going to have the ability for people to pick what we want to do. So I'm going to make a little poll over on the Twitch side. And what the poll is going to be, what topic do we want to go through? Right? So what topic do we want to go through? And there's going to be network security. Bastion hosts patching and there we go. All right, I'm going to make that a 10-minute poll. So if people want to, let's go to view results. I think I can watch this in real time. Let's see here. Can I view the results of the poll? I think in real time we can watch this. So let me pull this out over here. This is what you guys are voting on. What do we want to do? What do we want to do today? And I guess people that just kind of got here early can kind of decide for everybody what we're going to do. And we will probably hang out and work on that stuff, whatever you guys vote on. And then we will also work through, I don't know, I'll probably pop on and answer some questions and stuff. But mostly we're going to be watching recordings I already have for the Professional Linux Users Group Security Engineering course over there. And you guys get to choose pretty much whichever one. If it's a tie or if nobody votes, then I'll just pick the one that we're going to do. Probably we'll do, I don't know, it might be fun, kind of fun to do user access and system integration. That might be a good one. Or maybe bastions and air gaps. Bastions and air gaps did have my favorite little parts of the presentation of anything that I've done recently with the group. So I made some pretty good little labs and stuff in there. I think all the labs are good though, so we could just go through all of it. But we only have so much time. My wife is gone. She went to dinner with one of her girlfriends, and then she's gonna be back later, and we're gonna hang out. So I figured I'd try to kind of hop on and hang out with you guys a little bit. I probably do have some work I need to do with one of my customers, so I'll probably be working on that stuff later tonight too. But I figured I'd hop on here and kind of hang out with you guys. We'll do it a very similar format to earlier. It's pre-recorded, but I'm also going to be hanging out with you guys. So I'll be sitting here typing and doing stuff and probably even playing Brotato or something while we're kind of hanging out. So you guys can talk to me on the Twitch or the YouTube side as we go. And I will, answer questions. I can even stop and come back to this and dig deeper into things if you guys want. But your choice right now in the poll is network security, user access, and system integration, integrating to any other stuff. Hey, Paul, how's it going? Hopefully you vote. Nobody's voting. So, and then you've got Bastion hosts if you want to learn about Bastions, patching and enterprise patching type stuff that we do. And then the last one is kind of from the bottom, the certificates and stuff. So I will go over any of the stuff that you guys want to. We're mostly just going to watch the recording of me doing it, and then I'm just going to sit there and type. I feel like it's kind of like riff tracks. I just kind of tear myself down a little bit and kind of be self-deprecating and have a good time. Paul, how's it going? You can vote if you want. Nobody's voting, or I don't see anybody voting. So maybe I started the voting too early. Maybe I need to give people a little bit of time to get in here before we just jump right into voting. That might have been the better way to do it, right? But yeah, we'll see. We'll see if we get some votes in. I'll take into account votes over on YouTube as well, if anybody wants to type those in. You only see 3 on Twitch. You should see 5 options there. 1, 2, 3, 4, 5. You only see 3. Huh. I think you should see my whole screen. But it should let you vote in your chat. Let me see. Hold on. Let me drop down over here. Huh. I see 5. Oh, yeah. There's only 3 people hanging out with us. Sure. Paul, which is much smaller than normal, but I did just kind of jump right into this because I left and I ate and I did that college class and then I hopped back on over. So we can definitely do patching. Patching is the one vote we got. You guys on YouTube, if you see something that's interesting to you there, just I guess your vote is typing it in. That'll be your vote. Now, all of these topics are already recorded up on YouTube, but we're just going to kind of hang out and watch them and do it as like a little riff tracks, which I think is perfectly acceptable way to do what is it, Tuesday night? And then Paul, you said you moved, but I'm going out to Mexico from Thursday through the next Friday, so we're going to be out there for a bit, hanging out, me and the wife, a bunch of our friends. Should be kind of good. Should be kind of fun. All right. Well, looks like Patching's going to win in early voting. Let's see how this turns out here. It's nice up there. Yeah, Paul, my brother Tommy's up there right now. He was in Coeur d'Alene for a little bit, and then he moved over. Now he's at my brother's house, and then he's coming home in a few days. So the day I'm flying out, I think, is the day he gets back home here to Phoenix. So he took my truck up there, Paul. So I think that's kind of funny. Took my truck. I got his little electric plug-in car, which is kind of funny. But all right. Well, I think we've almost given it all the time we got. We got about 3.5, 4 more minutes on the voting if anybody wants to vote. But otherwise, it looks like Patching's gonna get it. So I will drop us into studio mode and get that set up. It's likely gonna be Patching, which was Unit 5. All right. I did Paul, he drove up. He took my truck back, oh gosh, before the 4th, because he drove up and then he was up there. So whenever I went up there, I think it was like late June, whenever I was up in, I was in all the way up in Idaho. I just went over to Colorado, and then he was driving by me. It was actually funny. I was flying out of Colorado Springs probably as he was driving through. So I thought that was kind of funny. All right. Getting down to the last little bit. Here's your choices, guys. Network security, user access and systems, bastion hosts, patching, or certificates. You guys pick. Looks like patching is the current leader. Patching is winning the race right now. Oh, we got certificates. People want to talk about certificates a little bit. Do certificates if we needed to. If we get a tie, oh, you guys can also use channel points for votes. You're not using your channel points for anything else. All right. Well, almost done with voting, so then we'll start what is likely going to be. Well, actually, yeah. Again, if it ties, I get to choose. So maybe I'll pick Bastion Host because I think that one's fun. I think that one might be the one that people want to see too, but we'll see. I think that's the one that has more of the funny images in it for sure. I spent a lot of time on that one, just putting together AI AI bullshit. All right. Well, then we will give it till the end of the poll here, and then we'll go. I think I actually have patching set up. Patching was 5? Yeah. Okay. Well, I guess that's what we'll do here then. No last votes. All right. We gave it our best shot. All right. I'm flipping it over, and we are going to watch the patching. That's going to be our one for today. So let me flip that over. Start that one up. All right, let's get right to it tonight because this is like our third time trying to record this. So there shouldn't be any distractions today, and we should get right to it. So let's get into Linux Security Engineering Unit 5. This is a free course provided by the Professional Linux Users Group. All you have to do is join our Discord and go hang out down there with a bunch of other engineers. Presented by myself, and let's go ahead and get right into it. So what are we talking about this week? There's some announcements. There's the, if you got questions, ask them down in the Discord. There's a lot of people that have been through this stuff and can kind of tell you about it. This is our 5th class meeting. We actually met this last Saturday, but I'm recording it today. We've got an annual virtual conference coming up on the 8th, 9th, and 10th. I have just the 9th and 10th because those are the 2 official days, but we're going to kick it off the day before so people that want to come and hang out. We typically have, this is our 2nd time doing it, but we've had kind of conferences. We have over 100 people come to those, so it's pretty big. We have a lot of speakers from around the industry come and talk to you guys, so that's pretty good. All right, so last week we talked about 3 major things. There was jailing users, and then I had a discussion that you had to go do about jailing your users. And then we talked about what an air-gapped system is. And then the relationship between those is the fact that when we're jailing users, we can use that to create this bastion, a bastion of entry for a not truly air-gapped system. Air-gapped systems, you don't really see many that are 100% air-gapped. So we jail users, drop them in, let them connect through, and then we get out of there, right? I have some stuff last week where we walked through it, and I showed you guys how that all worked. So that was last week. You did some notes, and you did Bastion Lab, and I think everybody really liked that lab. It was a pretty good one. So this week, we're going to do 2 things. We're going to build repos, and we're going to do enterprise patching. Those are the 2 overarching themes for us this week. We've got a worksheet, and the worksheet is a place for you to get your notes out, write down some topics. Maybe this is your first time ever hearing some of this stuff, so you're like, oh, that's kind of interesting. Let's go see what's kind of going on there. And then we'll go into enterprise patching. And I have the framework of an enterprise patching tool started, and then we can add as much to that. Actually, I have like multiple things still to add to that, but the lab itself is up, and then I actually have a kind of bounty for you guys to go and add to that. You can do pull requests against that. So then, this week, take notes, read all the materials from the worksheet, and then we have repos and patching as our lab. So let's get into it and let's do it. I try to keep these under about an hour, but we'll see how this one goes as we kind of get into it. So our overview for this week, like what is control and why is control so important for security engineering? Like if we're talking this week about how software gets onto our system and how we control the locations that the software can come from, and we also control who can configure those. Well, if we lose control of that, if anybody can just patch our systems in any way and they can set repos wherever they want, you can't, if I as a platform and security engineer offer stability of systems, but anybody can change that system, I don't really have any control over that stability anymore, right? And then we talked a little bit about what is fit for use. Fit for use is just the checkboxes you can make as an engineer. If we're talking about a web server, is the server serving, is it an Apache or an HTTPD web server? Check. Is it running port 80 and 443? Check. Is it, whatever types of things you would check? Is it serving out from its document root the paths that we expect it to? Check. Those are all fit for use type things. And as engineers, we love going through and just check boxing things, right? This is what we like to do as engineers. Fit for warranty is, do I warranty, and I always talk about this as kind of like, do I bet my weekend that I'm not going to get called out, that this thing is going to continue working? Is it going to continue running? If you have the 5001st connection to that server, does it continue to serve on port 80 to the back end that we expect it to, right? So that's fit for use and fit for warranty from an engineering standpoint. And for security, as we're building repos and allowing access into a system, it's almost like the same Bastion concept that we set up before. We're controlling who can come in through a Bastion host. We're controlling who can come in by what software repos we're going to allow our system to use. So we're going to do those in the lab. So why do we create a repo locally? Maybe we want to share something local. Maybe we're in an air-gapped environment. Almost everything I build for like government customers is going to be in an air-gapped environment eventually. So we set up local repos so that we can just pull everything off of our head node or our controller node. So that's a good reason to create a repo locally, is I can control both the content that's in it and I can control who has access to it because it's a local repo that I control. How do we create it locally? We're going to do that in the lab. How do we share it over the network? We're going to do that in the lab too. And then how do we configure our repos? Well, once we have a repo set up, how do we configure our repos on the machine for our machine to know where to go and connect to? We're going to do that in the lab as well. That's in a location etc yum.repos.d, typically in our Red Hat environments that we're going to be in. And then I asked, how does enterprise patching differ from one-off patching of systems? So all of you have probably, some kind of cell phone or something, and you push a button every now and then that says, okay, go ahead and update, or you say wait, a day. But what's really required there? I mean, you have to have your device, and it has to be powered on and have enough battery to finish, and they tell you not to turn it off during it, so can't really use it probably for a little bit of time during that patching. But really, at the end of the day, that's simple. Like, they've done a bunch of testing on the back end, hopefully, before it got to you. And then, like, one-off patching really just requires me to hit a button and say, okay, and then hope the device comes back up. And if it's bricked, then that means it didn't work. Then I got to go take it to somebody and fix it, or if I have my own tooling to fix it, whatever, right? Well, that's much different to just hitting a button on your laptop and updating to the newest version of like Red Hat Linux or something. That is much different than going and hitting a fleet of 1,000 servers. Those 1,000 servers we'll talk about all the things that can happen there. And then what's lifecycle engineering, and how does it relate to patching? Well, life cycles mean that we have things that are short-lived, or they have a certain amount of time that they're going to exist for. And in life cycle engineering, if we're talking about life cycles, we are talking about typically a patching life cycle. So we're going to download some content, we're going to use it through its life cycle, and then we're going to throw it out and get new content. That's what we're going to do in our patching. So we're going to talk a little bit about how that kind of works, and then we'll go from there. All right. So repositories, we can host ISO or RPM. So ISO is your format of like CDs and stuff. And we used to get physical CDs and go put them in physical machines, but we don't really do that anymore. We just mount ISOs. And we can mount .ISOs over IPMI interfaces. And there's all kinds of different ways. Like if I were to pull up my home lab here with my XCP-NG, I have NFS ISO shares, and I can just pull them up and put them in any machine. And that's great. We can host repositories for software out of there as well, and we're going to do that in the lab. Or if we just had a bunch of Red Hat package managers that we threw in a directory, we can create the XML file that would cause that to be a repo. There's a tool out there called Create Repo. It's an awesome little tool. It will make the repomd.xml that's required for your DNF or YUM to go and pull that information, right? So there's this value here. Anyway, so we can host these locally. So we can host them on a machine and then just use them. And then we can also remotely host them from our network over something like HTTPD. So HTTPD is a fork of Apache. All other things inside of it are still typically called Apache. The user is still Apache. but on Red Hat style systems, it's been forked, so it's HTTPD. So anyways, when we go and look at it, we'll go find where that repomd.xml is that defines the structure of that repository. So that'll be how we do it. It'll kind of look like this. I told you guys, I also dumped these up in the Discord as the raw files if you needed them. But typically your DNF or Yum as a package manager is going to read whatever global settings, your etc DNF, dnf.conf or etc-yum.conf or whatever file you're using. This is actually, it's funny, etc-yum.conf is literally just a link to this file now. And then it's going to read whatever global settings. Do I have any excludes? Do I have anything that I'm not going to do in this patching, like as a overarching configuration? Then it comes down and it reads these repos. There's a Red Hat repo, there's EPEL, that's extra packages for enterprise Linux. And in our discussions this week, we're going to talk about why we may or may not want to, as an engineer and as a person representing an enterprise, use extra packages for enterprise Linux. In your home lab, sure, throw whatever you want in there. You find a package that seems interesting, go add EPEL and add it. But if we're getting support from a company, and if it's going to be part of like a package tool chain and something that's going to be supported in prod, we really have to consider EPEL a little more deeply. Then just my internal repo. So what we're going to do in the lab is we're going to cut these out, get rid of them. And we're going to build one of these, which will just point to a local file. We're going to do that off an ISO, and you guys are going to get to see how that pathing works. Then when we're done with that, we're going to share that out over HTTP, and we're going to change our definition on our repo to point to the HTTP version. And once you did that, you would be able to connect any number of machines back to that one machine as kind of like a centralized repository, because that's really what it is. And then you could control patching for that whole environment from that one machine. And this is kind of the crux of what we're doing. Now, some of you might very quickly go, well, hold on, Scott. Couldn't I, instead of this pathing and all this repo stuff that you're talking about, all this control that we're going to manually do, couldn't I use a tool like Satellite or Pulp or one of these other things that does all that for me? Yes, that is actually why people pay a lot of money to Satellite, is to do, well, it's Red Hat Satellite, right? To do this for us. But what we're doing is we're picking up the individual pieces and going, oh, okay, I understand the security implications. I understand what I'm doing. The fact that we then go use a tool to do it for us just makes our life easier. In fact, originally with this lab, I had intended to apply Pulp to it. I will make labs in the future in Killer Coda that have us pull down Pulp and lock in the versions of the repositories. I just didn't get to it this week. So we're going to understand the pieces, and then maybe we'll circle back to it next time we run the course or something. But anyways, we come down here, we can use or not use a GPG key, which will allow us to verify it's an out-of-band management, that when we download something from a repo, we have a key that was sent separately, and we can validate then that it is something that has not been modified in any way on the system. So that's cool. That makes us feel good and know that we are only patching things from, the officially supported vendor and all that stuff. And then it comes down, and your DNF or package manager, right? That's your package manager, is going to store metadata and download the packages and then go ahead and install them if it's supposed to. This is the repository side of things, and we're going to do this in the first lab, right? The second part of this, when we get down into patching in the enterprise, I said patching differs from just pushing a button on your desktop and saying, okay, I'm going from Windows 10 to Windows 11, or I'm going to get the new Mac. I don't even know what Mac updates look like, but I imagine they just come down as updates of some type. But this is the challenge that enterprise patching involves. And I've done this, probably a good portion of my career has been putting automation to this. So this is a big portion of what I do. Here's some challenges. If you only have an inventory of 980 machines, and you're supposed to patch 1,000 machines this weekend, well, you're not going to be able to patch all the systems if you don't know what they are, where they are, either by name or DNS or resolve locally in some way. If you don't know how to reach those machines, you're what we call SOL. Who knows what SOL is? Shit out of luck, right? Anyways, if it's against multiple machines, they can be in any number of states. Maybe a machine's up. Maybe somebody turned some machines down this weekend, or they were doing other updates on them. Who knows, right? So we need to kind of control how the machines are handled as they come in, and I show you a little bit of that in the lab where we do the repo, not the repo side, but on the patching side, we'll go look at some of the things that are happening. Systems must point to a controlled repo, otherwise they're pulling anything external. So if I don't ever set my machines to use something local that I control, they're just going and using something. Well, if my dev machines pull down all their patches on the first of the month, let's say, and then the prod machines or maybe our test machines, which are another environment, they pull everything down on the 14th of the month. Those patches they've moved to new versions and things have been updated. I have no control over that. This is why we pull down and lock in a version of the software. And we're going to talk about what that process looks like here in a second. But they must be a controlled repo. If you're not controlling your repos, you might as well just be like, I don't really care if the system stays up. Because you have no idea the stability of it. You've tested nothing, you've baked nothing in, you've made sure, you've done literally nothing to guarantee anything, and you're basically setting yourself up to fail. So, all right. Patching always introduces new variables and instability, so you must apply it to lower environments first. You will almost always hear me say dev, test, QA, and then prod. Those are typically the 4 that I use. I've worked in environments that have had 17 environments before we got to prod. It's just it's whatever the standard and rigor of your organization is. But generally speaking, we have dev-like and prod-like. And the difference between them is prod is customer-facing. Prod is and by the way, when I say customer-facing for a security or an engineering team, I don't always mean the customer that's paying you money. I may mean internal customers that are running batch jobs and whatever other things are happening across our Linux servers in a fleet of 1,000 servers. Probably, in 1,000 servers, maybe 200 of them are facing out towards customers and APIs and these kind of things happening. The rest of them are probably servicing internal batch jobs and all kinds of other things, right? Oh yeah, Linux developer. I wiped last night's stream completely. Yeah, because we died halfway through the stream, so I didn't get through everything. So I'm redoing it. All right, so this is a way that patching might occur, but I posit this is the archetype. Like this would be like your outline of a story. If I said, hey guys, we're going to write a Cambrian myth, and you're like, I don't know what that is, and I say, I don't either, but I know that there's this archetype, and this is how the story kind of flows, right? This is how patching works. Patching tends to be that we're going to sync or download to something we control. That's the first thing that has to happen. And let's just say, for the purposes of this discussion, and actually this is a very valid one that I used at a big insurance company, we're going to do that on the first of the month. So on the first of the month, we're going to suck down all the patches into Satellite, and we're going to call that the beginning of a life cycle, and we might just call that life cycle May 1st, 2025. That may be what the start of this life cycle is, right? And the first thing we'll do, if you have time and if you have enough engineering resources, maybe people are going to review CVEs and impact and all this other stuff. But for the most part, we're going to patch all. There's bug fix, errata, and security updates. Those are the 3 major ones. We're just going to apply all of them for the most part. But we will typically exclude kernel unless kernel rises to a level of like 7 or 8 or 9. And then we'll patch kernels like every 3 months or something. It just depends if we're going to reboot systems or not. There's all kinds of things, again, that, we're like, let's say we're baking a cake here, and that's getting into how you're going to frost the cake, and that's a little bit more of something for you and your organization to discuss. But for the purposes of this, you're going to download everything on the first of the month and lock it in. Boom. Now I control those patches. And the first thing I'm going to do is release those patches into a dev environment. So on the first, I will make that life cycle available to my dev servers. My dev servers can then patch whenever we're ready. Typically, we can patch dev servers during the day a lot of the times in an organization. We will patch the servers, and we will start to do the initial, what we call a smoke test. Smoke test is kind of a funny thing for us tech people, because what's a smoke test? Well, we turn it on and see if any smoke comes out. If the smoke escapes, it's not good, right? That's a smoke test is a very bad thing. But basically, does it turn on? Does it turn on and off? That's a smoke test. We validate that, and typically like the dev teams and whatever, we're going to validate, like, does the software still work? We move to a new version of maybe Tomcat and HTTPD on a server. We are a heavy Java company that runs those. Well, we need to make sure that whatever apps our team has baked up still at least turn on in that environment. Or are there all kinds of errors? And then we now need to start thinking about updating those things as well, right? So now the teams are involved, our issues, whatever, and we start to move forward. And when that's good, and when we call those 2 weeks of testing and bake-in period good, we're going to move those out to like our test and our QA environment. So we're going to move that locked-in version that had only been exposed to dev. We're going to expose that to the test and the QA environment. And then we're going to go ahead and say, now let's patch these. And we're going to get more testing, and we're going to do integration testing and not just turn it on, but we're also going to go hit APIs and connect to databases and make sure all those things are working. Whatever types of tests you're going to have involved. App teams and QA teams and all other people are probably going to be involved that were maybe sleeping back here for the first part of the month, right? And we're going to check everything that we can. And when we're ready, we're going to then take that's now been deployed to dev and test, QA, and we're going to deploy it down to the prod environment. Now, again, these graphics are up in the Discord if anybody needs them. But then we're going to put them in the prod environment. There's going to be some acceptance testing, what they call unit, or they call this user. I say unit acceptance test. That's what I've always called it. And all the regression testing is going to happen again. And is the patching still working? This is still pre-prod here, but again, how you bake this, how many layers you put into it is really up to you. But then app owners final checks. Maybe you have change management approval with your change advisory board. I am used to doing changes this whole time, so we're always putting changes in all of our environments. Some companies are not that. Some companies are more loose with the lower environments, right? They're not as worried about it. Do we need to fix anything? Do we need to troubleshoot anything? Do we need to rip any patches out because they're causing specific problems? That may be when you go and evaluate the CVEs a little deeper and go, this one's not really... Like this security patch is good, but it's not really tied to a CVE, or it's a CVE of like 4 or under. And we're like, the company will eat that risk because we have other things in place, right? We have to understand our risk profile for that. But then we come down here and we patch to prod. It says apply patches carefully. I would put an asterisk there. Let's apply patches as like an engineering, in an engineering way. And I'm going to show you guys the start of like an engineering patch playbook that I started, and that's what you guys are going to do for this lab. And then everybody's going to verify your ops team and monitoring tools are going to be applied directly to these. It probably will be in those earlier ones too, but maybe not as rigorous. Every team is going to be on typically when we're patching. We're going to be calling them out throughout the night to validate their stuff is back up, and all the customer facing stuff will be good. And then if we need to, it says right here at the end, rollback plan if severe issues. Well, hopefully we found any major issues. I've actually had to roll back out of major kernel patching before, and it was only because there's one thing that you can't apply in any of those earlier environments that, and in this case it burned us, the kernel burned us. You will never get load testing and stress testing until you get to prod. You can't generate the type of load that your actual production users and when workloads happen in your lower environments. You could try it, but even if you have things that replicate how the traffic works, if you're dealing with like the dynamics of people calling in and these other things that happen in a real environment, you can only get that really out there. Now let me say for a second, you may be able to generate that nowadays with AI, and you may be able to spend a lot of money and replicate that. But even then, until something gets to prod, we're just really hoping that it does the things that it says it should. I mean, we could do, it's one of these things, we can make all the plans we want. If any of you ever saw The Way of the Gun, the very last scene in the movie when they're about to have the big shootout, he tells them, you want to make a plan? He goes, nah, plan's just a list of things that don't happen. We can make all the plans. As engineers, we love making lists and checklists and all that stuff, but sometimes things don't work. So this is a way to do it, but the little asterisk right here around the apply patches carefully, that's going to be our patching portion of the lab. All right, so review. Why is control important? Because we have to keep, we're talking about confidentiality, integrity, and availability, and the availability of the system, the uptime of a system is the key performance indicator for any operations team. Your operations team and you guys that are hanging out and doing this stuff, you're either administrators or engineers in these environments. Your number one thing is keep those servers up. Keep them up. Keep them doing what servers do, right? So control is so important because if we're just letting anything in, any package, any whatever, we're allowing the introduction of anything to the environment, and that's a problem. So then we talked about fit for use and fit for warranty. Fit for use is checkboxes. And the engineers love checking stuff off. And what is fit for warranty? That is, does it continue to work? How does it operate in the wild, right? How do we create why do we create repos locally? So that we can have control over things. and control. That's how do we configure our repos to point to those things. Now we control what packages can be added to our systems. How do we create a repo locally and how do we share it? We're going to do that in the lab here in a second. And then how does enterprise patching differ from these one-off systems? Again, the one-off system, you just hit, next, finish, and it patches. Hopefully it works. But in enterprise patching, we have all these different layers to it and all these tests and kind of like stage gates that we want to go through. But we have to patch our systems because vulnerabilities are always introduced. CVEs are constantly coming out, right? And it's actually funny. They almost stopped coming out a few weeks ago, but that wouldn't have stopped the vulnerabilities from existing and people finding these problems. All right, anyway, so let's keep going. So if you have questions, ask them down in the Discord. We're going to get into the labs here. And we will start, before we get into like the lab proper, we are going to get into before we get into the lab proper, we're going to start with the worksheet. Oh, hold on. Not the lab first. Worksheet first. So the worksheet shows you guys what you're doing for the week. If you're doing the course, again, course is free. You just go hop down the Discord and start it. We're halfway through this one, so I'm not going to tell people not to start it. I think it's valuable, and we have all the recordings and stuff. But I would also tell you, you might not finish it for the certificate this time, but you can at least start working on it and getting your stuff. Learning stuff is always good if you ask me. You're talking to a guy who's starting to work on his doctorate again. So, all right. Anyways, let's go into our discussion questions. So, discussion questions. If you are doing the course, you have to do 2 of these a week. You have to respond to one, you have to respond to each one once. So 1, 2. And then you have to respond to somebody else on each one. So there's 4 total discussions. I know I'm a monster, right? Making you think about stuff. The first one is review the Rocky documentation on software management in Linux. Okay, so I come here, click this. Hopefully it pops up right here. Good. And here is the software management. They've got some pretty cool stuff that shows you how the versions and the releases go. Red Hat has this really good thing, and by nature of being the same, Rocky, is the EL8 and EL9 specification. So you don't get this in all versions of Linux. You don't always get this in all packages, but in Red Hat and Rocky style patches, and this Red Hat is the base Linux, right? You get EL8 and EL9, so you know which version it's for. So if you ever open up a folder and it's all a bunch of EL8s, you just back out slowly because you're in an EL9 environment and you go find the right packages, right? You're obviously in the wrong spot at that point. But they talk about a bunch of things, and the questions then are, what did you already know? What did you learn or pick up? People have been answering that. You can go look at what answers people have already given. What are the DNF plugins? Those are near the bottom, and there's some pretty interesting ones like version lock. Version lock, you can lock something to a specific version. And you might say, Scott, why would that be important? If you're doing Kubernetes, guys, and you want to keep kubeadm, kubectl, and kubevert, kubelet, all on the same version, you can use version lock to help facilitate that. And that doesn't mean you couldn't come in and build stuff manually or even install stuff with RPM, but it means that your tool that you should be installing things through, like DNF, not one-off, using DNF as a tool, will help you to keep that version lock in place. So it's one of those extra things to kind of keep people happy. Also, it's really bugging me that that's like that. So I'm going to say add the dictionary. All right. And then what is EPEL, the extra packages for enterprise Linux? And I said, why do you need to consider when using this one, right? One of the things that you're going to find is EPEL is never, so if you're paying CIQ or where CIQ does Rocky Linux or Werewolf, they support it. And then Red Hat obviously supports RHEL. But if you're putting EPEL packages on your stuff, they don't support those packages. So now you've got this other thing to consider. Am I going to use something that's unsupported? Yeah, sure, they'll still work within the OS, but if you put in a ticket that's about that specific package, or they drill down and find that package is the major piece, they're going to close that out and say, look, sorry guys, that's not something we support. That's an unsupported configuration. You can't be doing that. It's the same thing I tell you guys with like building kernels and compiling kernels are fun, but you will never do that as an enterprise systems engineer. You will not. You will do it in your lab for fun, and you will ha with your buddies and stuff. You won't do it for real, because it would never be supported. It would be like if I had a fleet of GMC trucks and I built an engine and put one in, and then I took it to the Chevy dealership or the GMC dealership and said, hey, fix this thing, my truck doesn't work. And they're like, what the fuck is this engine you put in it? They wouldn't do it. It's the same exact thing in Linux, guys. So anyway, so you got to think about support. Now, again, we're always talking about, like, as hobbyists in our home lab, we do whatever the heck we want. It's the wild, wild west, right? We're just shooting off into the sky. It doesn't matter. But in the enterprise, it absolutely 100% matters what we do. And all of our decisions roll down from the things that we do. So this is very important as a engineer. Okay, second question. Do a Google search for patching enterprise Linux. Try to wade through all the noise. Everybody's going to try to sell you everything. When you do that search, you're basically pinning yourself up for a bunch of just people trying to sell you stuff. And I said you can look at blogs or AI if you want and enumerate the list of steps or checklists to patching enterprise Linux. I'm going to give you one in the lab, but we're stepping back and saying, well, what does AI or a blog or some other people say? I don't want you guys to just have my opinion. I'm one guy who's been doing this a long time. I may even be overly cynical about it because I've patched literally over 100,000 servers in my career now. But if you're just taking like patching points, probably closer to 1 million nowadays. If you said every time I had patched a server, it'd probably be closer to 1 million. But this is why automation's so important. I'm not going to each of those and doing a DNF update. Anyway, so we'll look at that. Patching a fleet of systems differ from just pushing update now on your local desktop. What are your major considerations and what are some roadblocks? All right, so that's the worksheet, right? And I apologize, guys. I'm not trying to ignore chat. I just can't. I can't focus on it. I got to get this out. This particular recording has failed too many times for me to not just take care of it. All right. So definitions and software, or definitions, terminology, some things that I think that you should go look up if you're newer to this or if this is your first time playing with any of this stuff. And then here's some things that may be useful to you from the class or just lecture in general. Other tools that we're going to use in the lab. Here's the lab, Unit 5 repos and patching. It's up in the Discord as a PDF, and the guys have also been working very hard to get it into the book. We do have a book that goes with this course. It's free online. If anybody needs it, just let me know. I'll link it. And then I always have this digging deeper sections. You do not have to do the digging deeper sections. They're not part of the actual course, but they're just a bunch of things, and neither are the reflection really, but they're for you. Like, I tell you guys all the time, and I say it kind of tongue-in-cheek, but it's true. If there's 30 of us in a room doing like a lab for like a training, I'm going to be number 1 or number 2 being done. And you guys might not believe me, but I've been in enough training to know I'm normally going to be 1 or 2. I'm not going to have learned a goddamn thing. I'm just going to have rushed through it as fast as I could. When I go back and reflect and look at it again, that's when I pick up and learn stuff, guys. I'm telling you, like, I just put my head down and I just go, right? I'm just tapping like this on the keyboard. But I don't learn anything. And then when I go back and reflect, that's when I pick up a lot of things. So, oh yeah, maybe I learned a command or learned some nuance of a way something works. But anyways, all right. After completing this lab, how would you deploy a software repository? How are you going to update it? What tools do you find that are useful? So Pulp is one that is really good. It's actually upstream from Satellite as well. And then this is a big one. Why are repos controlled by root admin functions and not just anybody like it's the wild, wild west? Whenever you hear me say something like it's the wild, wild west, I mean just everybody's doing whatever they want. There's no rule. There's no rule of law, right? So there's that. All right. So that's up in the Discord. Let's go to the other one now. We'll get into the actual lab here. So the lab's going to start like this, and it's going to say repos and patching, get PuTTY or some tool. Guys, I never prescribe how you connect into a system. I use PuTTY because I've been using it forever. But however you get into a system, and I say go download your Stig viewer. Now, I already have a Stig viewer, but if you don't have it, you go download it. By this time, if you're doing the course, you've done the Stig viewer in 3 of the 5 labs now, so this will be the 4th of 5 labs, so you're probably gonna get used to that. And then I say go download the Stig for Apache 2.4. So Apache 2.4 is there, and you can import it to your viewer, and then make a checklist from it. So then, before we get into the actual lab, I also say go look at the InfiniBand drivers. So let's see if this pops up here. Control, click. There we go. And I'm going to link this to you guys if anybody wants to do this with me real quick. But in the lab, people would be doing it. Oh, yeah, let me link the book real quick. Hold on. Somebody asked for the book. Give me 1 second. It is right. This book is right here. So this is the book for this course that we're doing right now. I'll link it over on the Twitch side too. And then this stuff is all getting added still by the guys. And it'll be like the Unit 5 stuff. So it looks like the guys have been adding Unit 5 stuff as well as we're going. So that's really good. Now, what I wanted to show you guys here on this Mellanox thing, I'm not going to make you do this in the lab, but I do want you to see this, is we could come down here and we can see how Mellanox OFED, so these are a type of driver for ConnectX cards that we put in for InfiniBand on our system. And let's say that I had a Rocky box. So up here, RHEL, CentOS Rocky 9.5 is what I use in the lab, x86-64. Here is the ISO at 225 megs for, and here's the SHA 256, so I know I downloaded it without anybody messing with it. And then I can go get that. And then what I say here is go find your version of choice. So maybe you're a Debian enjoyer and you're on Debian 12.5. And maybe you're on Arch. Maybe, maybe you're using an Arch 64 chip instead of an x86 64. Here's where it would be. And by the way, if you guys don't know, Arch is actually kind of popular in the HPC world. Not in a lot of them that I work in. I work mostly. I'd say I work 95% x86 64, but I do have some clusters that have Arch on them. So just different architecture. And really, you just need to watch your packages because, other packages won't work on there. So anyways, I show you this because this is an interesting way. If you've never downloaded from like a vendor, this is how you actually download those. Now, in the lab, I already have that downloaded, and we don't ever mount it unless you do it in the digging deeper section of the lab. But just I want you guys to see that there is software out there available for you from different vendors, and you would pick the version of whatever operating system you're using to run that software on it. And these are drivers and software that works with what we call InfiniBand, right, as a network. I need to get an InfiniBand switch in here so we could make the back-end network of our systems really fast, but for now we're not there and we won't worry about it. But that's the pre-lab stuff. So that's before we get into the lab. So now let's go to the actual lab here. And the lab has three things we're going to do. We're going to do these STIGs. We're going to get the STIGs going. Then we're going to build all our repository stuff. And then we're going to go to Killer Coda, where everybody can be if they want. And we're going to do the patching, enterprise patching. So I'll show you guys that. So right here, I say this lab is designed to have the engineer practice deploying patches in a Linux environment. This is a skill that I think it can't be overstated. This is a valuable skill for you as an engineer. So before we get into it, we look at the STIGs for Apache. And the reason I did that is because we're going to turn on HTTPD in our environment. And if we wanted to harden it, there are 47 rules here that we might need to ensure that we are locking down. And I say over here that we can start part of this process. We're going to install Hammer on one of our Hammer servers. We're going to install some stuff here in a second. And then we can go look at the STIGs. So let's go. I'm on Hammer 25. Systemctl stop www client. This is the Werewolf client. We're stopping it in this environment so that it doesn't affect our... What happens is every 10 minutes it goes and it updates the etc passwd from the cluster, and the Apache user wouldn't be on it, so it'll wipe our config. We're just going to go ahead and bypass that, so we'll just turn it off for now. We're going to say dnf install -y httpd. We're going to install that. And it's already on. Okay. And then systemctl start httpd, and then we'll just check the status of it if we wanted to, and it's running. And maybe if we really wanted to go deep, we'd say ss-ntulp, and there's our port 80. Boom, we're on, we're listening. We could do lsof-i on port 80, and there's no space there. There's no space there on port 80, and okay, we see it running. Cool. Everything's going. And now I say check the STIG here. So there's a STIG for 214234, and it says that the Apache server must use a logging mechanism that's configured to alert the ISSO. Well, that sounds like something outside of Apache. Apache doesn't do that natively. So in the next labs in Unit 6, we're actually going to set this up to capture the logging from our system and send it somewhere. We're going to use some different architectures that I've used professionally, and then I'm going to challenge you guys to go find some other ones and maybe build some ones that are interesting to you. The ones that I'm mostly used to using heavily is rsyslog, and we've got a lab on that. And then also the other one is Promtail to Loki. That's another one that is very scalable. So we'll look at that. And the STIG says to send stuff off. Well, we're not doing that right now. So since we're not doing that, we're going to leave that as an open finding. And then we could maybe go in there and say this is not, this is not currently. But it is a detective. It is a technical detective control in our environment. So that's what we're asking over here. What is the problem? We're not sending logs anywhere with alerts. What is the fix? We'd need to implement this or integrate this with that system if we had it, which we don't right now in the lab. What type of control is being implemented? It's a technical detective control because it's looking at logs after something's happening. It's not physically stopping anything. It's not, so it's not a technical preventative control. It's not physically stopping anything, so it's not a physical preventative control either, but nothing inside your system ever will be. And is it set properly on our system? No, it's bad. Which is why the checklist is cool, because then you can keep track of all the things. And you could just keep going through these. I have 214248, 214. Oh, this one's also bad. We need to make sure that the directories that Apache runs out of, that's our etc httpd, ls-ld, ls-l, they are owned by root, but they are traversable and readable by anybody. That's what all these mean. Everybody can traverse down in here and read stuff. So what we might do to resolve this is if we wanted the Apache user to be able to read down in here, we would make the group right here, the group owner of all of this. We would go, this is what we would do. We would cd up one, we would ch own root Apache to the HTTPD, and we would do a dash -r, right? And then now, cd back to where we were. Now the owner of the directory is still root, but the group owner is here. And then we would have to do one other thing. We would have to strip off these last permission sets for everybody else. That's the O, right? The others. So we would have to strip off these permission sets and leave only the 750. That's what we would have to actually do to lock this all down. We're not going to do it right now because that would take too much time away from the lab. But I just wanted to show you guys that this is how we can keep track of things and this is how we can run everything. How's it going, Michael? We're just recording this lab for Unit 5 right now. Well, we're recording the whole course, but I'm on the lab. This is all up in the Discord under Prolog projects as well. So now we're going to build a repo. So the Hammer server is ready, right? And we're going to cd to etc yum.repos.d. And what? Oh, you know what? Hold on, guys. Let's reboot this guy, and let's sh2 hammer 24. I got to start that part over because I had already done it. I think I did it the other day when we were all talking. All right, hammer 24 uptime cd etc yum.repos.d. Okay, he's got all the stuff. So let's start real quick. We got to do those three commands: systemctl stop www client, because we don't want client mucking around and changing our etc past wd. DNF install -y h2d. Oh, I'm pulling this right from there, guys, right from the documentation, right in my lab. Then we're going to do a systemctl start HTTPD, and again we could be hardcore and do our ssntulp and see that it's running. Cool. lsof-i on 80 if we want to see. Again, how much do you want to validate this before you start with the lab? All right, so we're going to cd into, so we're going to clear the screen up, pwd, we're in etc.yum.repos.d, and we're going to make dir for old archive, right? And then we're going to move anything that has a repo on it into that old archive. Now when I ls-l, there's nothing in here. And just for fun, DNF repo list, I have taken away all the repos my system has. Now, you might say, Scott, how do you know you had any repos? You might be lying to us. I literally just installed HTTPD with this, so I had to have been going somewhere. I was going somewhere, but now this box is going nowhere, right? He's like a song from the 80s. You're going nowhere. Anyway, so going nowhere fast or something. Anyways, so let's go look real quick in, I have this directory out here, lab work. And again, if you're just putting your head down and running through it, you'll just blast through all this. But in here, I have two files. They're both ISOs. One is Mellanox-OFED, and ls-lh in here. And Mellanox OFED is the kind of smaller 224. We're not really going to use that unless you want to play with it later. But then we got this 11 gig big old DVD ISO of Rocky Linux. We can install anything we want off of this. So let's CD back over to here, and we're going to continue on, and we're going to touch. We need to mount it. I didn't mount it. I was just looking at it. We're going to mount -o loop that directory. So lab work repos. And then Rocky, right, to /mnt. Now, a lot of times we don't put things directly into /mnt, but for the lab environment, we'll do that. I would normally make like a mount /ISO or something, or even a mount /Rocky for fun. But if we do a df-h, we'll see that mounted down here now. And for fun, if we wanted to, we can go examine that mount point. We can ls-l and /mnt, and then if we were to like ls-l mnt base OS and then repo data, yeah. Here's that repo md.xml that I was talking about earlier that actually defines how, that's actually where your DNF is going to go, or your yum, whatever you're using, probably DNF nowadays, is going to go traverse down to find that. So this is actually what you can modify if you want to change the behavior inside your repos as you get to doing this. First, we just got to make one. After that, we can go do whatever we want. All right. So we're in our directory. Let's touch etc yum.repos.d. And the reason I use full paths every time is I never know where you're going to be when you're doing these labs. You know, you might have been wandering around. So I'm always trying to be as absolute as possible. And then we're going to go ahead and VI that file. Just VI it. You're going to drop in here. You're going to hit I, and you're just going to go copy all this stuff I gave you right here. All this stuff. Boom, boom, boom. But then I ask you, as you're doing this, escape:\W for just now to write it. And I say, go ahead and save it, however you're going to save it. And I say, do the paths that we're looking at make sense? Okay, I got file is file, and then these 3 forward slashes, but the 2 forward slashes are part of the definition. And it's mount base OS, and that's pointed at this base OS packages Rocky Linux 9. And then the app stream is going to app stream from that mounted ISO. I think that works. Let's test it, right? Let's test to make sure that it works, and do a DNF repo list. And we should see those 2 repos now. But I'm not satisfied with that. I want to make sure that that's what it was using. I know we just blew everything away and we just did it, but let's go VI that file again. And let's call this, just for the sake of today, prolug. That's our professional Linux users group. Let's make sure that this is being read. This is for sure what's being read in our DNF repo list. Yeah, there. See how the name changed? I don't make you do that in the lab, but this is one of these things I like to test things and validate them to myself, that things are working the way I expect them to. And then I might say, one thing I like to do is chmod 644, that directory. So etc yum, or that file, repos.d rocky 9. Just make it readable, just so there's no problem. And then DNF clean all. And we're going to make sure that it removes any caching or anything that might have been there to affect it. And then we're going to go test the repository. So we've already tested that we can see them, but can we install something? So we're going to do a silly little thing here where, just look at what's happening here in my little delete. So DNF, we're going to disable everything. So there were 2 things. There was AppStream and base OS. We're going to disable both of them. Just go down to base, nothing. And then we're going to enable only AppStream. So we add 1, right? I mean, we have 2 now. We're going to go to 0, and then we're going to go back up to 1. But it's going to be AppStream. And we're going to list all the available stuff. We're just going to dump it to the screen. And it might take a second, but it's going to read all the packages. That's a whole lot of packages. Well, it might not surprise you to know we can say number line and then throw a head on it to see the first 10. And we could go, okay, the first 2 lines here are kind of BS, so we don't need them. But then I just run number line, and again, I have it all over there. And I have 5,589 packages in AppStream. I'll probably give or take 1 or 2. That's a lot. And that's what's on that DVD. And we could go validate. We can go look at any one of these in the packages in there if we really wanted to. But that's being given to us through the repo AppStream. Now we could do the same thing again and disable the other repo now. So we're going to disable the all repos, funny enough, and we're going to enable only the base OS repo. And now we're going to, and so now what we had 5589, right? And now we're going to go the other way, and we're going to say, we'll do NL and then head, and see that the top two don't really count. Okay, good. And then we'll take away the head, and we'll say that this one has, I believe this one has, yeah, almost exactly 1,000, right? So that's cool. That's fine. But can we try to, maybe can we try to install something? So we can install something like this right from that system. And, whoops, you guys might notice that when you copy it out of there, it's going to have the letters, but I don't think that happens on the PDF. So let's run this, and let's say that we want to install GIMP on the system. GIMP is the GNU image manipulation program. It's got about 582 megs. That's kind of a beefy, but it's a GUI, so it takes a little bit. So we're going to say no on that. We don't want it. But then how many packages did it want to install? 173. That's not a lot. I mean, I try to keep, like in my high performance compute systems, I try to keep myself under about 400 packages when I build. But typically over time we build out like the most lean, lightest. Like if you had a drag racer, or if you had a drag race car at the strip, you would want it to be as light as possible. In fact, they express that in racing as the amount of horsepower as a ratio of your overall poundage, right? So like you have 600 horsepower in a 1,000-pound vehicle, that's a pretty good ratio, right? And you can go look up, there's a whole bunch of that crap. But over here, we can see AppStream and base OS. So I could tell that these things are coming from both of those, so we needed both of them enabled for that to work. Okay, that's cool. That's a good start. But now what if we wanted to share out the local repository? So we have, if we cat out the Rocky in here, we are sharing this locally only for us. What if we wanted to allow other systems? Remember I was saying how we're air-gapped from last week, and now we've gotten a hold of this ISO. Maybe we had to bring it in through security. We've put it up here, and now this one machine can patch itself. But what if I want all my machines to patch off of this 9.5, right? Maybe we could do that. So let's say RPM QA grep for HTTPD. We know it's there because we just installed it, but there's some packages. System CTL status HTTPD. Got it running. ss-ntulp grep 80. And you guys might say, Scott, this is, a little basic and you're making us do the same thing. Yeah, but for people that don't do this all the time, for those of us that like touch this stuff literally all day, guys, this is kind of basic. But for guys that are like trying to get out of other jobs and get into doing this stuff as an engineer, you've got to touch, the more time you're at the keyboard, the better. So just remember, a lot of this stuff, if it's redundant to you, you can skip it. I'm not going to be like, you skipped 4D, you're out of the course, get out of the Discord. I might do that to you, but I'm probably not going to do that to you. Anyway, so let's go. Let's do we've got a web server running, but what is it showing us? It's not really showing us anything yet. So let's go into our Etsy HTTPD conf.d directory over here, and there is no repos.conf. So we're going to vi repos.conf, and we're going to dump in this little definition here. And look at this. There's two directives. Well, actually, I asked the other day and nobody bothered to check, but if any of you want to correct me, I actually don't know. The engineers love correcting things, right? I know that this is a directive, and I know that this is a directive, because that's what you do in Apache config files. You make directives. I know that this is a directive, and I know that this is a directive technically. I don't know what this is. It's an alias, but I don't know if that's an alias directive. So I don't know. I was saying the other day, we do two directives, and then, oh shoot, do we do three? I don't know if alias is considered a directive. I know it's like a keyword and a command, but let's just look at what we're doing. Whatever. If we're doing two or three directives, doesn't matter. But we're going to take the directory /mount, and we're going to allow it to be shared out. And then we're going to alias repo to mount, and then we're going to let repo/repo have the same permissions. That's all we're doing. Basically, we're taking that df-h on mount that we have mounted over from that ISO. Now, if we were doing this for real in like a permanent environment, we would probably bring that ISO over and mount it. We would copy this mount to some actual file system location. But for the lab, it doesn't matter that much. These are ephemeral machines. They just go down, they're stateless, they come back up, who cares? Right here, this is what we're building. This is where it's coming from. And now we're going to share it out. So I've set that configuration, systemctl restart HTTPD. And the first test, again, the smoke test, it didn't break. Okay, it says it's working. Systemctl status HTTPD. Whew, okay. My HTTPD didn't, because if you break those, and I know this because I wrote them, that will for sure break everything, right? Like your HTTP won't come back up if those are wrong. So let's go edit our Rocky 9 instance to no longer be pointing directly at MNT, but up at HTTP on our server. So let's clear the screen up. CD to etc. Excuse me. It's like still cool in Phoenix, but it's kind of dry. Sorry. I just had like an itch at the back of my throat that I didn't get water too fast enough. All right. So now we are going to cd to etc yum.repo. I'm not crying. I'm not crying. You guys are crying. All right. Anyways, VIR Rocky. We're going to take this. We're going to take this file, this line here, and comment it out in both. And now our base OS. Now you could just copy all of this, but I think it's better to see what's happening here. I'm going to go here and I'm going to say YYP, and then I'm going to change this here to match what I see over here because I want to understand the difference. I'm going to go HTTP now. Whoops. And then I'm going to say Hammer 24. In my lab, it's Hammer 24 because I just jumped down to 24. You guys will be whatever Hammer box you're using in the environment, right? Repos, base, OS. And I go, okay, repos is that mount alias, and then base OS. Okay, cool. Then down here, I'll say YYP. Whoops. Whoops. And I'm going to change this one to go to HTTP Hammer 24, right? 24. I could also do it by IP, but most of us like having some kind of name resolution going on. Repos, and then over here is going to be app stream. All right? And you do need, well, it's better to have that trailing on there. And then we're going to escape colon WQ or ZZ. I say you could do it however you want to save. And then I said, do the paths that you've modified make sense? Yeah, if my Apache is serving out what I think it's serving out now from what we just did in the repos.conf, I think that this makes sense, right? So now there's this old saying in engineering, one test is worth 1,000 expert opinions. We could sit here with our corncob pipes for the next 2 hours and be like, I think it'll work. It might. Well, or we could just go fucking make it work, right? Like this is DNF clean. I don't know where I was going with that. I'm probably just losing my mind. DNF repo list. And now I'm still seeing them, even though I've changed that config. So that's a good sign. But let's see if we can install something. Can we still install that GIMP package? We didn't install it earlier. We just said go ahead and pretend to install it. You gotta clean up that Microsoft Word garbage there. But anyways, hold on. We're failing. Base OS could not down. Oh, interesting. Did I break something? Hammer 24, Hammer 24. Did I spell them right? Oh, anybody see it? Well, and also, this is an excellent time to talk about fat fingering stuff and assumptions of things. There's just a couple S's in the way. It's an excellent thing to show you guys an error, but it's not really intended. All right, it's repo, not repos, right? So now we run it, and it's going to everything in engineering is chutes and ladders. Something points to something else, points to something else. Get an API call, do whatever. DNF looked through and found the same 173 packages. We're going to tell it again no, but yes, our system was working over that HTTP connection, not the file connection anymore. And you might say, Scott, do we really do that often? Well, I mean, it depends how air-gapped your systems are and how you bring software in. But yeah, I've had to do this a fair amount in my career. depending on what I was doing and depending on what type of clustering tool or software we were using. So, all right, good. So that's that lab. That's the whole part. You can take that and go, I finished it. Let's go over here and let's look at this other lab. So I prepared a lab for you guys on this for Killer Coda. So if you would like to follow along with me on the Enterprise Patching Lab, I will link it over here on Twitch, and I'll link it over here on YouTube. It's also in the book. I'm pretty sure the guys already added in the book. But as we complete this Killer Coda lab, we're going to look at all the roles that are in the playbook and do we understand how the custom facts are being used? And can we think of better ways to use them? Because I don't really use them that much in this. I just wanted to get it out. What are the pre-checks doing? What other ones might you add? And then what does the reboot task do? And how does it check for the reboot to be needed? Now, real quick about this. There's two things that have to happen for this system to reboot, and I'm going to show them to you. But I want you guys to think as we're doing this, and as you see that I pull this down from a separate repo that's public repo, I have a bounty out right now for two different things. If people want to take the repo that I have and make it better in some way, I will. I think I'm doing a humble bundle for the first two people that do that. One person already did it, but then they said just pay it forward to the next guy, and I said, all right, fair enough. People in the industry that just want to do it for fun. He gave good recommendations that you guys are going to see when we're doing this. We actually added one layer of verbosity so you can see more. But now let's go ahead and let's do this. It says, welcome to the Prolog Enterprise Ansible. And it says down here, this is an Enterprise Ansible patching lab. Set up your environment to work with the rest of the lab. All right. So we are going to get clone down from this repository that I have that's just an HPC deploy. I just have a whole bunch of roles and tasks and stuff going on in there, all roles that are inherited. And then we're going to CD in there, and we're going to look at it real quick. And there's just a bunch of stuff going on in here where you can go look at all of it, right? But for the purposes of this lab, this isn't the sandbox. There's a sandbox version of this that's one thing lighter, and then you could just mess around with anything you want in there. In this one, we're going to set up... We're going to do a package update or deploy in our environment. So it's always useful if you're using Ansible to look at your host file. And our host file says, well, okay, we got a control plane and a node 01. Those are our two nodes in a two-node cluster on Killer Coda. And control plane is app web, and node 01 is appdb. So whatever we're doing in our cluster, he's going to become a web server, and he's going to become a database server, rather. So... And then the type client and server dealt with NFS, if you do the NFS one. But anyways, let's run this playbook, and let's look at what's going to go happen over there. So the playbook is O3 deploy. It's going to gather some facts, and it's going to push over some package. This is just debugging variables for us here. Actually, I'm going to spread this out so it's a little easier to see for right now. And then... it's going to install Apache 2 on the one web server, but it's not going to do it on the other server because that's a database server. And then it's going to do the the MariaDB deploy over there because that's a database server, and it's not going to do it over here. Okay. So let it do the MariaDB. And again, because we used a -v, it's going to be a little more verbose, and you could kind of watch it. All right. In this lab, or in this deploy, so let's go look at this file real quick. So O3 package deploy. We did package install, then we did a fact push. That fact push is going to be very important. So let's CD down into roles, right? Real quick, if you're not super familiar, we've got this roles directory. We'll CD down into roles, and let's go look at fact push real quick. So what is fact push doing? If we CD into files, there's some files here. There's a DB patching fact and a app web patching fact. Okay, so we see those files. But when we go to actually push them, we push them over as the same name of a file, patching.fact and patching.fact, regardless of how they started. So you might note here, you started as DB patching fact and web patching fact. But as you got pulled in and stamped to all the servers, everything's a patching fact. But it's different per server. And really, it's just, if you're a database server, you're a database true. And if you're a web server, your web server true. And then all of these other things that are getting stamped are just like, they're both app servers. Oh, look, apps. Don't worry about that. That's not part of it. But I do need to clean that up in the lab eventually. Like app servers should be true or not. But they're both app servers, truly. So then we go and we say, okay, I get what's happening there. And I get that I'm stamping that down. But what's that doing on my system? So on my system, if I cd to etc ansible facts.d, on this system, we got that set of facts. Now, Ansible, when you run setup, it will look in etc ansible facts.d for anything that's in here by name, patching.fact like this, will become ansible underscore local dot patching. And then you can use that in your playbooks going forward, as long as when Ansible first sets up and does its gather facts or its factor or whatever you're doing, if you're just doing setup commands, it'll go and it'll pull everything that it needs. So that's pretty cool, right? So let's get back to where we were. And the next thing it says to do, can you see all these variables? Can you check all that? Sure. We come down here and we go and we look at this. I'm too far down in the hole now. Let's go look at this one. And can we understand what the enterprise patching might look like in a company? Well, we're going to do a pre-check. Maybe we're going to do a fact push again, and maybe that's going to be with whatever newest version of files we've pulled out of like a CMDB. So our fact push could be something a little more robust than what I actually did, and if somebody wants to write that up, they can. We're going to patch everything, and let me see. Yeah, we're going to patch everything, and the patching is going to happen. We could also do some stuff around patching, and if we want to do some cleanup and stuff. But pre-check is going to check some things on its server. Fact push is going to push those facts. Patching is just going to apply patches globally, unless we do something else, which we could look into. And then we're going to reboot, but we're only going to reboot when Ansible underscore local dot patching dot rebooting equals true. So in these two servers, if you're in a database server, oh, where's he at? Hold on. If you're in a database server, rebooting for this week for this type of patching is false. And if you're on a web server, rebooting is false, whether you're in group 1 or 2, right? And we used to use different groups in our different environments, so that's why I added these, because then you could have groups as well, and you may pull these from a CMDB or something. There's a lot of ways that we could generate this, but the point is, we only reboot if the server's supposed to reboot on this weekend or this patching cycle or whatever. Then when we're done, we do some server validation, make sure that the server's healthy. Maybe we check some NFS mounts, maybe we check whatever. I don't really think we do anything in this one, but we could. And then we do app validation to make sure the apps are started, and we actually do that. And then we report out back to our Discord if we want, which I still have to set up, only when report is set to true, but it defaults to false. So if you don't give a report, instead of this breaking all over the place, it just says, well, he didn't want to report. If you don't set report to true, as you call this, it's just going to default to false, right? So one of these things where now what we want to do is go look at these. So we want to CD down to roles. We're going to actually, we can do this. We can do this from where we're at. So let's just CD up one. We'll stay here. And then let's cat 04 just so we have it as the last thing in our history. And right from here, we can dive down in. We don't actually have to move. We can cat out roles, right? Pre-check. We'll start with pre-check. Tasks, and then main, right? So all of them are going to look like this in relation to where we're at. And what does this thing do? This thing goes, although pre-check, it's actually funny. I have an error in my logic. I'm just going to show you guys this because hopefully it makes this better for you. My pre-check is before my fact push. So really I need to put, because look, if I just said, remember I just said, what if we had a new fact push? We would want that to be pushed before the pre-check, because in the pre-check, we're going to group by whether things are rebooting or not. And we're going to group the servers, and we're going to go for true in the patching. Well, what if that changes in the next play that's inherited? So that, like this, I'm breaking it all. But the point is, I'm showing you guys how you might do patching, right? So the pre-check comes in and it groups by the major distributions of Ansible. So now we would have a group that wasn't there in the start of this playbook. If we dropped 1,000 servers in and half of them were Ubuntu and half of them were Red Hat, we would know right here. And then we would have them by major distributions and all that stuff as well. So we could split them. You might say, well, what if you don't use the groups? Who cares? Then it's just a little bit of extra RAM that was used in the system. Now, for 1,000 systems, it's a lot of bit of extra RAM. It's not a little bit, but it's still, it's one of those things where it doesn't really matter that much. And again, we could comment it out if we weren't going to use it. We don't use it in this one. Well, actually, yeah, we don't use the grouping function, but we do group the things. So then we have them. Now, that's one thing. So let's go look at what's the next one. The next one is the fact push. So fact push is right here. But we already did it at the beginning of the lab. What? Fact under what? How is that not right? That's weird. Anyway, so this would be the fact push, and it would do that same fact push that we did at the beginning. And that's cool. Then let's see, what does patching look like? So right here, we would change this, hopefully, to just patch. What's patch doing? Patch is doing the simplest thing ever. Well, actually, I added to it a lot. So it is upgrading. If you're Ubuntu or Debian, it's using apt to upgrade all the packages to latest. If you're using Rocky or RHEL, it's using DNF to update them all. And then it's running the needs restart. It's needing, so in Debian and Ubuntu systems, need restart is the name of the command that's going to run. That's the package. And then in down here in Rocky or RHEL, it's yum-utils that gives you the needs restart. So we're installing a tool that will then tell us later if we upgraded a kernel or whatever and we need to restart the system. So there's actually two checks when we go to reboot. Is it allowed to reboot, and does it need to reboot? So, all right. Sorry, guys. My throat's like really scratchy now. Now, we got this roll reboot only when Ansible local patching .rebooting is equal to true. So we don't even go down here unless we need to. But if we do, what's happening down in there? Well, down in here, these are a little longer checks. Check for reboot requirements. So if you're on Debian or Ubuntu, and you know what's actually funny? Can I tell you guys something that's funny about this? I learned when I first started writing Ansible, I learned to put the when condition at the bottom. And that's how I've always done it. Even in blocks and stuff, I put it at the bottom. And I found out later, this was like actually only a few years ago. I remember I was working with this guy on a job Mac, and he was putting the when right under the name. And I'm like, that's fucking brilliant. Because then we just know right away if the condition's there or not. Now, look, guys, it's just, it's one way or another, however you want to do it. But I'm going to tell you, this is the way I originally learned. And I do prefer it right underneath. But it'll work either way. So anyways, look, you check for reboot, and you set register reboot check from if the system needs to restart for Ubuntu. We do the same thing for Rocky or RHEL, but the commands are different. You guys see that? So the commands differ. So I just did it as two plays. But we register the same reboot check because the return code, if the return code is equal to 1, then we set reboot required to true. And then we come down here and we reboot the system to apply changes, but only when reboot required is true. And you only dropped in here if you already had this one. That has to be true as well. So we have two checks here. And then we'll reboot the system if we need to. And then we'll come down here and we'll go to the next part, which is server validation. So go here and look at server. And server validation, I just checked uptime. Because then when I do my Jinja template later, if I expected a server to reboot, I want to report back which servers did not reboot. If I didn't want them to reboot, I want to check which ones are rebooting. So I probably need to put that in there as well. And that's going to be based off of the expectation of that rebooting true for this week or whatever. Because here's the thing. Some servers may not think that they need to reboot, but they were supposed to reboot. And I would want, that would be an anomaly for when we actually report out later in our final tooling. All right, so let's go look at one last one. So the last one is app validation. So we come here and we say app validation. And app validation was simple in ours. We said if you're an Apache server, if you were one of the web servers, then you should have Apache running. And if you're one of these database servers, you should have MySQL running. That's it. That's all I checked for. And then I registered Apache status and MySQL status so that then later on in my Jinja templates, I can report things out if I have a mismatch. And if any of you guys have ever seen how I report things out, because I do this literally every night, guys, in our Discord. We report things out. If you guys have ever worked, some people I know that are in the Discord or in Twitch right now have worked with me before. When I send things out, it only says the things that are anomalous. So in this case, like user logins to servers, this could be showing 44. We have 44 servers in the lab for people to log into. Why is it only showing these 4? Well, because they're the only ones people have logged into, and they haven't been rebooted yet. So those are all ones I need to go reboot. This Kafka one is always down, so well he would be a 45th server. He's always down, so he's always showing up here in unreachable. But if he's ever not there, I'm going to wonder what happened. But the point is, it doesn't tell me about the other 44 servers, because why would it? They're not in an unreachable state. I only care about the ones that are. And this is one of the things that you want to do in your pre-check. So when I did that pre-check earlier, at the very beginning of all of this, we want to make sure that we know which servers were down when we started. Remember I was saying that 1,000 servers you're going to patch? Well, and MPES is around. He knows. One of the worst things you can do at the end of a patching night is have 980 servers up and good and have like 20 servers sitting over there that nobody could get working. And you're like, wait a minute. Were those servers already up? Or were those down already? Oh, shoot. Wait. And then you're looking through like trouble tickets and you're trying to find like, you're going and looking for decommission orders and stuff on servers, and then you find out like 8 of them got decommissioned, but then you have like 3. You get all the way down to like the last 3 and you can't figure them out. Well, guess what? Now you're on the hook to fix them. Oh, they should have been down like a year ago. Well, you don't have any record of that, so it's your team getting them back up. And that's what the change management team's going to tell you too. Who's ever running bridge and stuff, they're going to be like, sucks to be you. Well, what I do, and Pessa would tell you this as well, we'll check all the servers up front. And that 1,000 just became 980 because we're not going to go troubleshoot those 20 right now. We're just going to take them out. And then now when I'm done at the end of the night at 980, I can confidently say to everybody, I patched every server that was given to us on the list and was available to patch at the beginning of the night. Because some people might say, well, your team should troubleshoot those 20 servers and get them up before. No. We're not doing that. We're not changing the plan. We're not going to, I guess if you want to think of it like Spock, the good of the many. We're going to do the good of the many, not the good of the few. Those things can get trouble tickets next week if they want. If we're on like a Saturday night patching or something, we're not going to deal with that. All right, so anyway, so we checked that all out. Let's run it, right? This is one of these things. Let's run it. See if it breaks. So we're here. Whoops. Let's execute it. See if it works. Watch what it actually does. It's going and pushing those fax files. It's upgrading all the packages, so this might take a little while. Actually, I think this part will take maybe upwards about 3 to 5 minutes, depending. So again, let me take a little time while that's going to tell you guys that the course is free. The course is right here. Right, this is the book. This is the book and the stuff. I think the guys already put the lab out there too. So look, they're doing a really good job. Here's the lab for this week. So the actual lab is right here if you want to do it. But also then you could navigate the book all you wanted. Book's free, course is free. You just got to go hang out in Discord with everybody. And it shows you all the stuff here. There's the lab. This is the lab that we're in right now. So we're good. How's Ranger doing? Ranger is sleeping like a log. All right. But anyway, so we'll let that run, right? And it's upgrading the packages still. It's doing its thing. And a lot of the stuff we're doing right now is building into, it's all the pieces, and then it's to give you the confidence that when somebody says, right, let's go back over here for a second while it's still running. When somebody says, do you know how to do these things right here? These are the things that we're doing in the course, and these are the things that I think when we're done with the course, you should be able to put on a resume. And if somebody asks you about, somebody says, hey, you said you understood how to upgrade Linux to resolve security vulnerabilities and reporting out to security teams. You could say, yeah, actually, I've patched systems with Ansible, and I understand how to build repos and update software on systems with controlled repos that we have inside the organization. I understand patching life cycles and those kind of things because I researched them and I did them in a lab environment. And I think that these are the types of things that you should feel confident when we're done doing this on putting on a resume. That's the whole point of this course, right? To help you guys get into the field if you're not in the field. So anyway, so this is all patching. You can look through it if you want and see what's actually happening in the system if you wanted to. It says right here, does this execute and what output did you see? And then I put a little bit of, again, in the Discord, I put a little bit of a bounty. If you run this and you think of a better way to do some of these things, do it, implement it, run it. I have to add the part at the end where we report this all out. And then for people that are in the course that want it, I will send you guys the webhook and you guys can deploy it up into the Discord and actually see your patching happen and then go over there. Also, I didn't dig too far into this, but this patching right here was designed to work against either Ubuntu Debian systems or Rocky RHEL systems. So technically you could do this same command from the beginning of this lab right here. This git clone right here. You could do this on your Rocky system if you're on one of these hammer boxes. Well, it's actually funny. You can't do it on this one, but hold on. Watch this. I'm going to move Rocky repo over to like temp for a second, CD into old archive, and I'm going to move anything .repo up one, right? And now I can patch. Oh, well, actually, I didn't need that for Git, but fucking don't even worry about me, guys. Also, don't do it in this directory. And then now here's my HPC deploy here, and assuming I have Ansible, yeah, I do, I should be able to run these same commands, and this should work just the same on this system here as it did up on my Ubuntu system, because it should be able to push that. I'd have to update the host to just point to like my local host and then probably some configurations there. But the point is, you should be able to get this working on your system if you wanted to. So there's that. All right. So that is, let's see, we went about an hour 20, so we went a little bit longer. We did all this stuff. And when you're done with the lab, so let's go complete the actual lab right here. So you finish out that part, and all the digging deeper in the labs, I always tell you guys, this is extra. You can spend time with this or not. But you've set up your local repository and shared that repo out so other systems might want to connect. Why might you do this in a fully air-gapped system? Well, because maybe I had to bring an ISO in, and then I had to mount the ISO and allow the software to be connected to. And I said, can you add that Mellanox ISO that I put in there and allow that to be a repository and mount that as a repository? And I think you could. I think you could make that, mount that in like /mount something, and then you could go and you could make those directives inside of repos inside of the httpd.conf and restart it. And then I think that you could make you wouldn't want to use the same Rocky 9 repo, but you could make a Mellanox repo and then connect to it. And I think you guys could do all those steps if you understood what you were looking at, right? And maybe a few times through that would be healthy for you. And then I said make a pull request to improve the enterprise patching tool that you just used. So that thing can use a lot of improvements. Even as I was using it, I was like facepalm. But the point is it ran, and you can see the logic of what we did, and then now it's on you as a security engineer to make that better, right? This is what we do as engineers. We look at something and go, well, that worked, but I think I can make it better, right? And that's a big part of what we do around here. So, all right. With that, I'm going to go ahead and call it for today on this stream, and then I'll probably jump back on as just like normal streaming here in a little bit. But I appreciate you guys all coming by, and I will see some of you here in a little bit. Take care. Okay, you guys should be able to hear me. So, yeah, that was just us watching the. Oh, let me get rid of that. Hold on. Put myself off of mute real quick. That was us watching a video. You guys kind of voted on it, which one you wanted to watch. I was gonna hop us in and do another one. If we were gonna do another one, it would be Bastions, because I think Bastions are kind of fun. And the reason we would do Bastions. Let me find this one other thing real quick. Where is that? This was the actual lab we were doing. Bastions would be Unit 4, so Unit 4 recording would be the next one we'd do. Alright. Oh, I did not mean... Sorry about that, guys. Hopefully I didn't lose all of you there. I probably did, actually. But if we were going to do this next one, it would be all the bastions. That's the one that I have prepped up if we want to do it. So, yeah, I'm not working too hard tonight. In fact, I think the wife should be coming home here soon. I just wanted to get some of these other ones that we've kind of recorded and worked through before back out there so you guys can see them. You guys can kind of see what we did in the courses. And I think the Bastion one's kind of fun, so we'll probably play that one next. But you guys are welcome to hang out. I am sitting here doing, I'm answering questions and stuff as people ask them. So we're just hanging out and doing whatever we're doing here. So I'll hop on this one, and then if you guys have anything, just feel free to ask me. If you need to, you can always ask stuff down in the Discord, and I'll get back to it whenever I see it. So, all right, I'll see you guys here in a little bit. In course that the Professional Linux Users Group is putting on. All right, let's get right to it this morning. So we are getting into Unit 4 of the Linux Security Engineering course that the Professional Linux Users Group is putting on. My name is Scott Champagne, and I'm kind of the guy that's put a lot of this stuff together. All of this is free down in our Discord. You guys can go hop down there and do the labs and do all the stuff with it. So this is my recording. Some people came yesterday and actually saw the course, but now I'm going to do the recording for you guys and put it as part of the group. So let's get into this week's announcements. This is our 4th class meeting. There's a reminder that we're doing an August big meeting down in our Discord. I think we're even doing 8th, 9th, and 10th now, so we're going to have like 3 days of it. A few hundred people tend to come to that over the course of the day. Attendance is free. You can invite others. It's all fair game. So, all right. And I have people coming from all over the industry to come talk to you guys, people that are experts and just kind of doing stuff in their individual fields. So that's always something that you guys are welcome to come do. All right. So what did we talk about last week? We talked about the pluggable authentication modules and how those work inside of a Linux system. We talked about the kind of like the directives and, what does it mean that something's required? What does it mean that it is a requisite? Like there's all these different things that can happen, but the pluggable authentication modules are how you tie into authentication on the system. Also with that, we built our own Open LDAP. We built our own Open LDAP on our server and then connected it with SSSD so that we could see how that worked. And then I asked you guys some questions about them, and you had to do some discussions with the group and that kind of stuff, right? So if you're doing the course, you're doing discussions with everybody and kind of, getting some ideas around how different people are looking at this. We have a worksheet for last week and then a lab on identity and access management that had you build that Open LDAP and then connect into it with OpenSS or with SSSD, right? That's last week. This week, we're going to shift gears again, and we're going to do air-gapped systems, jailing users. So those are our 2 topics. And there's one other thing that comes out of this with air-gapped systems, because we never fully air-gap a system if we really still want to be able to use it. The last thing about it will be a bastion, the idea of a bastion host and bastion protection around our entry points into our air gap systems, because again, we can have an air gap system and completely protect it, but then it's not useful. We have to have some way for users or entities or processes to get into the system, and we're going to jail users and turn hosts into Bastion hosts today. So that's what the projects are going to be, and that's what we're going to do. We've got a worksheet for you to take notes, and I highly advise, if we're doing a course like this, that you have like a notepad up or something. I'd keep my notes. I give you guys my notes. All this stuff is available for you guys, and you guys can always work through it. And then we're going to do a lab today, which is on Bastions. We're going to jail users, and then we're going to turn a system into a full Bastion. And then one of the guys pointed out, I'm going to also make another lab on the Ansible side that will deploy this automatically for you guys. So if you guys want to have that as well. I also have it up in my GitHub. So where do I have that? Over here. Up in my GitHub, in my stream setup, I actually have a Bastion creation script that I use personally for letting you guys into the Prolog labs. So if you've ever done the labs or connected into our system, and then you get that set of things that you're allowed to do when you hop in, and those are the only things you're allowed to do, you either get kicked out or you pick one, that's what we're going to build today, is the same Bastion system that I use. So we'll get into that here. So here's our overview. What is an air gap system? How does it work? What are the benefits? And how does that tie into our security controls? So an air gap system is a system that is completely away from any other systems. You can think of it like kind of that idea of Magneto in that cage where they keep him away from metal, right? It can be a system that's completely separated from any other systems. So how does it tend to work? Well, we put it in its own network. And then the only devices that are allowed to ingress or egress are the ones that are coming through connection to multiple networks. So we've got our own network separation, and we'll draw that out, and I'll show you guys the deliverable on that we actually give to customers. What are the benefits? We're going to look at some of the benefits of an air gap system, how it provides us the ability to kind of slow down our patching process, slow down our moving forward, and kind of, if you look at like a technology and like a patching adoption curve, we can kind of be on the slower end of it. We don't have to be up on the front end of that. And how does it tie into security controls? Well, it's a technical preventative control that keeps users from coming in any other way except for our defined method. So it gives us a lot of ability to think about how our controls work in the system. In fact, one of our questions later will be around bastions and zero trust. If we have a good Bastion system built, do we still need a zero trust? And you know, obviously the hotness in the industry right now is everything needs to be zero trust. So people are going to say yes. But my thing in this course, the whole thing I've been trying to show you guys as we adhere to STIGs and look at compliance and stuff is it's not just about blindly checking boxes. It's about understanding the concepts of what you're doing and being able to discuss it and have that back and forth with a security team, right? We're on the Linux engineering side of it, but we still act as security for our systems because, and to be frank, and you know, about as frank as I can be about this, the security engineers don't know Linux for the most part. Some of them might hack around with it and play with it, but they don't know it like you're supposed to know it as a Linux security engineer. So my point is you are doing things that are correct for your system and the risk profile of your organization, but you have to understand these things. So the STIGs that we've been doing and how they all tie in, this is kind of the things that we're going to get some familiarity with. So if we have an air gap system, what's a Bastion system? Well, a Bastion system is how we're going to allow users to come in. It's that one ingress or egress point into the castle. In this castle, it's being stormed by penguins. There's one ingress or egress point over here. If you remember the Battle of Helm's Deep, right, there was one place for the orcs to come up, and then they blew the side out, and then they all could come in the little courtyard area, but they still had to come up to that one door. So there were only two doors to get in that place. That is the bastion of those two systems. That is the concept of a bastion, and it's an area that we can easily defend. We can cut a bastion. We could stop all connections to the system. These kind of things are kind of why we build them, and how we build them. Well, we're going to spend the rest of the time doing labs on that, so that's good. And then what does it mean to jail a process? Why do we jail a process? How do we jail it? And how do these topics all relate to each other? So we jail processes down so that they think that they're in a root. It's called a CH root jail, and or some people call it a cheroot. I've always called it a CH root. I don't care how you say it. It's not a real word, so you can say it however you want. But I've always called it a CH root jail. Some people do say chroot. But yeah, we can drop somebody in, and now they are down in. They're not in the actual slash root of the system, so they don't have the normal set of binaries /bin and /user bin, and whatever their paths are go off of that directory, right? So we're going to build one var chroot, and when we build that, we're going to have to populate it because this process won't work unless it has some things that it can do. So we're going to understand that if you're in the process, if you're in the business, if you go in the business of jailing people, well, I just want to, not be morbid for a second, but explain something. If you throw people in a hole and you don't give them water and like a bathroom and like maybe a little access to light every now and then, you're not in the business of jailing people. You're in the business of burying them, right? They're just going to die down there. It's the same thing with processes. If you throw processes down, I'm going to show you how to build this little jail. It's super easy. And then if you throw a process down in there and cause it to be jailed, but don't give it any ability to have like a dev null, which is a trash can, and like /bin and executables like bash and other stuff, well, it's not going to do anything. It's just going to die. The process isn't going to work. It's not going to be able to execute anything. So we have to, there's this kind of, always in security, there's this push and pull between being absolutely secure and giving some permissions which lack security but give more productivity, right? There's always this ebb and the flow. So when we jail a process, we use that. There's other ways to build bastions, but that's how we're going to build a bastion. And then that's going to tie in to protect our air gap system. And I got this question yesterday. I thought it was really clear, but I'm going to say this because somebody did ask this yesterday when we were doing this live last night. Well, I thought air gaps were completely off the network. Well, that's what I'm saying. If you just took a computer and put it completely off the network, well, okay, true, it's air. That's the definition of an air gap, but it's not useful anymore. So we have to back off a fully air gap system. No system I've ever worked on is fully air gapped off. It's always got some access to another network, even if it's another like top secret network or something. It's still got access, right? So these are the concepts we're going to go over today. All right. So air gap systems, they are a computer network or single computer that is physically isolated from all other networks. There's no other way for the traffic to get in besides what we define, including the internet or any other local area networks. This isolation is achieved by ensuring that the air gap has no network interfaces. I put an asterisk there, connected to any other networks. And I say we don't completely isolate. There will be some traffic in and out, but we're going to define and we're going to control those control points. It's like a choke point. If you want to think of it as we force somebody down into the valley so we can have a good ambush, that kind of stuff. There's other benefits to bastion systems. Like if anything ever happens in our lab and I need to cut all access to all users, I can do that through the bastion. I can just turn off the bastion and that kicks out all users in our systems. It's the same type of security protocol. So that's how air gap systems work. Now, come down here. This is an example. This is an example I built for a customer. It's not exactly for any one customer. This is still very vanilla. It's not directly for any one customer, but it's a actual deliverable that I would give them. I would have all their systems here, but I just have, these are generic node names that we kind of use. But I have 3 networks defined. There's a gateway network for how we get into their systems for the outside world. This gateway network establishes our bastions right here. So there's web application firewall. They had AI ML nodes, which are kind of login nodes for users. And then their data valet nodes, which are nodes that are specially designed to move data in and out of the system, right? This is the connection into a completely air-gapped system over here. Again, with just the asterisk that some nodes are defined to allow traffic in. Over here, they've got their own network of 10 gig Ethernet, and then they've got back-end InfiniBand, which is I think the InfiniBand in this network it's 200 gig links, so it's 400 gig InfiniBand for all these back-end devices, right? And that's the network. So this is actually something that I would deliver to a customer to show them this is your network isolation, right? So network boundary example, kind of a useful little thing to understand and draw out where the physical connections of the network start and end, because that's an important thing. If we're talking about no network interfaces, but now we're going to allow a few for productivity reasons, we should define what those are. Okay. So when we come down here, air gap systems have a whole bunch of benefits. They enhance security by isolating it away. We can move more slowly with our updates. We can stay versions back that we might have rushed up But maybe with our risk profile in our organization, we're saying, hey, I have compensating controls of being behind a bastion system. So yeah, those things like Log4j where somebody could just directly connect and cause problems. Well, that's not really a problem because they have to come in through our systems and they already have to be authenticated, and we would have all kinds of other problems. So we can kind of slow down some of the security patching a lot of times, and also we can keep systems slightly further back for stability focus rather than a security focus. So that's a thing. Protection against remote attacks, yeah. Like things have to come in through the one area. So if they can't bypass your security protocols of your hardened boxes, then they can't get in. There's no other connection in. There's no alternate way to connect to systems directly or any of that stuff. Malware prevention, even if one of your servers gets popped, one of your compute nodes happens to get something on it that it shouldn't because somebody did manage to upload it, it can't communicate out anyways, so it can't exfiltrate data. There's a lot of protection put in there, and that's right here, data exfiltration. There's only movement through the systems that you define, so that's kind of how that works. Data integrity, I don't know if I completely agree with this, but at least the idea that nobody can get in there and mess with it, that's for sure a data integrity thing. It doesn't solve the other problems of data integrity and that entropy can break down data over time, but that's a different concept, so it's not that big of a deal. Regulatory compliance, sometimes we do have compliance reasons to keep servers separate and then to be able to say, hey, we monitor all access into these boxes. Well, it's a lot easier with only 1 or 2 bastion nodes to come in. And then it's the last line of defense. Again, I can just cut I can cut 3 bastion servers and completely air gap the network for real, and nobody can ever get into it, and then we'd worry about resolving what was happening later. And basically we can stop all, like you see in a movie where they're doing something and the record scratches and stops and everybody looks. You could do that same kind of thing. You can stop everything. You're like pulling that little thing that stops the train or whatever. It's you have that capability. All right. So bastions, what are they? It's a controlled entry point to an air gap system. Right here. See all these little penguins are trying to get in again? But it's an ingress-egress point that we use to control and allow users access to and processes to access. So users and processes can get in, but we're defining that control here. All right. So we build bastions by jailing users and processes. So let's look at that next. Jailing in Linux, right? There's techniques to isolate a process or set of processes from the rest of the system. That's what we call jailing. There is the chroot jail or chroot. I don't care how you say it. It's not a real word, so you can say it however you want. System sees the root of the file system as some lower apparent root. We are going to use /var/chroot, right? That's how we're going to do it. There's also Linux containers. I have seen bastions where people log in and like a Kubernetes node stands up a bastion node just for your connection to come through, and then when you're done, it tears it down. I've seen different ways to do this. Our way is going to be the chroot jail, so we're going to build that a few times here today. There's namespaces where we virtualize various system resources, and there's a bunch of different ways that namespaces can isolate system processes. There's C groups where we can limit the account account of resource, CPU, memory, IO, and a group of processes. Even if you're not using this as a protection, it's a good idea to have C groups to limit when users log into systems and that kind of stuff. So, here's all our little Linux penguins in jail over here. All right, so let's build a jail and a bastion. I've got 2 labs. Anybody can get in them. They're going to be killer Coda labs, so I'm going to show you guys how to get in those. But the high-level processes are going to look like this. In our lab, we only have 2 nodes. So in the bastion that we're going to build, we got an outside control plane system. We're going to SSH over to a bastion system called node 01 and become a jailed user. And then we're going to pretend to jump into the air-gapped environment, which will be back over on control plane. I know it actually looks like this, but this is how it's virtually happening, right? So you just have to be able to play imagination for a little bit. This is what we're going to build in the architecture right here. This will be in the lab too, so I'll show you guys that. And then here's the high-level steps. We got to write a bastion.sh script. I'm going to show you that as we go. to lock the user in a jailed environment. And if we're going to lock a user down in a jailed environment, which you're going to see here shortly, we've got to give them some things. Like if we want them to be able to SSH, we've got to give them the SSH executable. Well, if we give them the SSH executable, they've got to be able to resolve network names. Otherwise, they need to know IP addresses. They need other libraries for SSH to work. And SSH doesn't work without some block devices like dev-urandom and dev-random. If you don't give them that, they can't do anything. So we're going to give them all those things, right? So this is our pre-deploy steps, and we're going to build this in the labs. And then here's the full Bastion deploy. This is like the full set of steps. Create a user or users to jail. So we need the users. Create a line in etc ssh sshd underscore config for the jailed user. Set the user to have a Bastion shell as their home. And then we'll create the var ch root. It'll be a little bit different in the lab. There'll be a user bin as well, so that's fine. Copy in the correct executable files, copy over their libraries so that they can work properly. Because again, if you don't have the libraries for your executable to work, it's not gonna work. So I'm gonna show you guys how to copy all those in, and then you got to make the devices so that they can interact correctly. So that's kind of, or that they can interact correctly. So that's our kind of labs there. So let's get into real quick. As we go over to that, which is going to be right, where do I have that? Here, we're going to hop in here. I'm going to show you guys the worksheet. So the course is run out of our Discord. We are in Unit 4. It is completely free. All you got to do is go hop down in our Discord and go to our Prolog projects, and you'll see all the stuff for the course. There's a bunch of discussions that people are getting into and that kind of stuff. But this is the discussions for this week. Unit 4 is going to be to review some of the blogs about air gaps and Bastion hosts, and then answer some questions about it. You can even use Google or an AI. I'm okay with that. My college students have to do a little different, but you guys are not my college students. You guys can run amok and do whatever you want. Professionals can do whatever they want, but I'm just, we're trying to learn things, so I make sure that you say, when you're using it, you let us know. And then it says here, do a Google or AI search around jailing a user. Can you enumerate the methods for how we do that? And we're going to do it in lab, so hopefully when we're done, you can step 1, step 2, step 3, step 4, walk through it. Here's some definitions and technology that definitions or terminology that I think that you should know. Here's some lectures and notes and other stuff. There's a little bit of digging deeper, things that I think you should go spend more time with if you want to get better at. And then kind of the reflection questions. And here's a question that I think is very important to all of this. Does it matter if a user knows that they're jailed? Does that matter to the system? Yeah, all right. Turn that off. All right, so that's that. And then let's go look at the lab. The lab for this week looks like this. And it starts off with, Bastion. Here's that same thing that we just looked at. And then it says the lab is designed to have an engineer practice securing a Linux environment via the use of Bastion hosts and jailing users. So first we're going to jail a user. So we're going to start with a lab that's been around for a while. And I'll link this lab to anybody that wants to do it with me. This lab is there for you guys to do. This one's been out there for probably over a year. And it starts with here. Your team is planning on building a Bastion system. You've read that the first part of properly Bastioning systems is to jail or lock down the users and processes. You've decided to build a jail to test the functionality. So build a jail at var chroot. Add basic framework to the jail so that you can populate it with some functionality. Change your root to that chroot and see what functionalities you have. You've given yourself some functionalities. Let's make sure that it works now. All right. So you hop in there. Again, these labs are all free. You guys can just hop in there. And first we make that var chroot. Then we go and we make all the directories that we need. There's a little bit of a difference between the directories that you need in Ubuntu and the directories that you need in Red Hat. So you'll note that in this lab, we do the ones that are needed for Ubuntu. If you go look at my stream setup over here, you will find the ones that are needed for, where's it at right here? These are the ones that you need for like a Red Hat system. And that's the way that I was doing it over there. Okay, but that's something additional. That's not part of the hard lab here. All right, so we'll ls and look at those and go, okay, they're traversable by anybody, right? They're 755, so that means they're readable and traversable by anybody. Perfect. So then we come down here, move in the minimum executables for chroot to work properly. So let's drop bash in var chroot bin bash. Good. And then there's a bunch of LDD. So let's go do an LDD on user bin bash. And you'll find these are the executables right here. These three that are needed for bash to work. Now you might say, what about this one up top? That one up top is going to error, but don't worry, it's not needed anyways. It's going to error when I run this little for loop. Because what I'm going to do is I'm going to loop over that output there, and I'm going to grab nf-1, which is this one on each line, and I'm going to copy it down into var chroot. So we're going to copy it over. Don't worry about that one little error. It even says right here, you can ignore that error. It's fine. Who cares? We're going to copy it over into var chroot and then the full name of the package, which is lib x8664-gnu. And these are the libraries now that exist for bash to work down in our jail. So ls var chroot lib x8664, and you'll see that it copied those two in there. Those two, there should be 1, 2. Oh, the other one just went over to lib64, so. The other one went in here. Yeah. So they went to the places that they needed to. All right, so we got those. Now we're going to test our jail functionality. We have very basic, very, very limited jail capabilities now. Let's check our current bash process. We are in 2657. You're going to get some different number than me because it's the process ID of your bash. And then we're going to chroot over into that jail. And now we're going to check our bash process, and we're in a new one. So 2837 was assigned. But let's try to do ping. No ping. I can echo because that's built into bash. So echo $$ worked. Who am I? Don't have it. ID, don't have it. PWD, I do have it because that's built into bash. But now when I exit back out and I do my echo $$, I'm back in my original shell again. And I have ping -c1 www.google.com, right? I got Google. I can PWD and LS and see these things that I necessarily didn't have down in that jail. So it's almost like I dug a little hole, put bash down in it. I jumped in there, didn't really have any capabilities, and then I jumped back out, and I'm like, whew, I have those capabilities again because I'm in a normal shell. I'm not down in the jail. So you're definitely seeing that you're in a different environment. You can go read more about what that process looks like and where it came from. I think there's some interesting history there. But for me, I want to, like, it's almost like, guys, if you go to the gym and you start like bench pressing and somebody starts telling you, this was invented by, George Hackensmith back in whatever. And you're like, I don't fucking care. I'm trying to get a bigger bench. It's the same kind of idea here. Sometimes the history of a thing doesn't matter that much. You want to touch it and understand the thing and get better at it. So I'm just telling you that the reading about the Wikipedia and all that kind of stuff, that's just extra stuff if you guys want to know a little bit more about it, right? But the history of it's not nearly as important to me as you guys understanding what you're building and how it works. So you've exited the jail. I already exited. And then now I can ping. But if I drop down back into the jail, I chroot back into the jail, I can try to ping and I don't have it, and then I can exit and get back out. All right, so that's the first part of the lab, jailing. And I say you've set up a jail and verified there was little to no functionality. It's basically just a hole with bash in it. You jump down in the hole, you didn't have any, you don't have anything to do. You don't even have a trash can. You have no dev null yet. We're going to build all that. We need to make the jail useful for a user. We have to give the basic pieces for a user. Well, and a user exists on your system as a bash process, right? Like, I mean, and then they call bash commands and other commands from there, but they can't do anything without these commands available to them from their bash shell that they have. So we gave them bash so they could exist down there, but we didn't give them anything else yet. So we're going to give them curl and SSH. Curl, SSH. Those are two things we're going to give them. And then we're going to copy in the link libraries needed for curl and SSH. And again, we can check those link libraries whenever we want. And then we're going to copy in the right environment files for that all to work. So one of the things I was telling the guys yesterday, and I'm telling you guys now because we're recording it for the class, for people that want to look at it later. One of the things you're learning now is that you take a lot of stuff for granted when you drop into an operating system. There's all this stuff that you have that's just there. But when you start building jails, you start to realize what your processes really need. So let's copy over some things that are really needed. You need passwd. You need group, because otherwise the processes in there can't render. They don't know what the IDs are, and they don't know anything. You need the nsswitch.conf so your system knows how to interact with the network correctly. And you need Etsy hosts so that you can get the host file and do some basic stuff like that. At the beginning of this lab, what you guys didn't see during the setup is in Etsy hosts, I put Google at the bottom. So that's something that I did in the setup of the lab when the system was spinning at the beginning. If you ever need to see that, it's over in in the GitHub. You can actually see how I do all that, right? You guys can build labs in here. This is a free site for building labs. Anyway, so we're going to come down here and we're going to say for binary in bin in bash ssh and curl, copy these in. So we're going to copy in the binaries that we need, and we can go check them. ls-l var chroot user bin whatever, boom. All I did was a little for loop and copied over them, right? Like, you guys can take that apart pretty easy. If you wanted to add more things there, you could, as long as they're in the right path. If you ever struggle to find something in a path, like you're like, I want to give them calce. Well, you say which calce, and if calce is on your system, it'll show you. If it's not, you got to install it. Let's say you want to give them ls. ls is in user bin ls. So if I wanted to give them ls, I would just add ls to this and it would copy it in, right? So there's definitely ways for you to go and mess with that. Now, I'm going to do a couple of these things just like we did earlier, and we're going to get those errors, but I want to show you guys what we did. We did an LDD on user bin SSH, and this is all the packages that SSH needs right here to work. Now, again, that one's going to error. We don't care about it. That's built in. But this one, all of these down have been copied in there, and we can go check that. ls-l on var chroot lib x8664. Now all of those ones have been copied in for SSH, and then also for curl, we can do the same thing. Bin curl. These are all the libraries that are needed for it to work. There's a lot of libraries, right? But you don't need to memorize them. You can know how to reference a thing, guys. So this is a very useful command. If you're ever having... In modern Linux, you're not going to run into a lot of like linked libraries failing, but this is how you check. LDD, user bin bash, and then, oh yeah, bash doesn't have the right libraries. Bash is breaking. Probably at that point, you're just blowing machines away nowadays, because like we build so many machines that like if I had something like that broken, I'd go, how the hell did that happen? I'd just blow the machine away nowadays, right? But especially down like a dev environment, I'd be like, look, man, I'll give you a shiny brand new machine. Just all your data's we already have all their data copied off because it was already remote, right? Like the machine for me is very much more ephemeral nowadays than it used to be. Now, but here's the thing. We got to give them a trash bucket, dev null. We got to give them a place to go poop. Their user. We got to give them a little window so that they can see things. That's TTY. We got to give them 0, random, and urandom. That's their ability to contemplate the universe. Those are just locate. So dev 0, dev random, and dev urandom is a way to query the processor for either a 0, a random that's based on entropy in the system, and urandom that's not based on entropy of the system, which you can go look at how that entropy and noise is generated by just reading a man page on it. I think you can man dev urandom. I think you can just man random, maybe? Yeah. And then you can go look at the difference between random and urandom. And actually, Robbie Reed, who sometimes comes and talks to us, he'll tell you a story about the difference between using random and urandom and how it actually caused them problems in building servers one time. But I won't tell his story. I'll let him do it. And then there's this one other thing you got to copy. You just got to copy all these NSS files. They are how your system interacts and how these things interact with the network. So we're just going to copy those all down there as well, so they have them. If you want to go look at what those are, feel free to just change the command like this and say, what the heck were we copying down there? You just do an ls-l, and it's all of these. These are just other libraries that allow your system to communicate properly with the network. So everything will work. Everything will work here now. You set up the environment, so let's go check and test that we have all the pieces in place. So we're going to test that the user has the capabilities that we've given them. We're going to add a user. I actually don't even use this user the way I'm supposed to. I'm just going to make them 1, 2, 3, 4 because I'm lazy. And then I'm going to chroot for our user. This is our root user. And I shouldn't have things like ls. I might have pwd because that's built into Bash. But can I curl www.google.com now? Yes. And why can I curl? Because I have down here I have a Etsy host file and an Etsy NS switch that says to use the host file. And in that host file we have Google, and then we allowed curl with its link libraries. So I have all of those things down in my jail now. I didn't have these things before. I also have the ability to now SSH. Oh, also I can exit the jail. Okay, good. And then I can chroot into the jail again. And then from here I can SSH back over into my own machine, but as the jailed user, we'll say yes. And then we just do 1, 2, 3, 4. This is weird because I never really used the jailed user like I was going to. But now we're out of the jail. We'll exit back. We'll be back in the jail. Don't have it. Exit out again. I'm out of the jail. And I'm back to the root user on the system. I have all these commands again that I didn't have a few seconds ago. So you can drop back in the jail whenever you want. And then you can check, you know, PWD works. LS does not work. You have all your file test operators. All the things that are built into Bash are there, but you don't have things like, I don't even think I have which. Yeah, so you can't even find things. Like, you're very limited down in this jail unless you give those permissions to somebody to use, right? So we hit submit to finish the lab. And that's again, these are all free labs, but that's a lab that you very much could just go do and then maybe do it again. And then here's the questions that go along with it. If you were to write out the high-level steps of building a chroot jail, what would they be? Could you draw those out? Could you say, okay, I know that there's just this location I made, and then I've got to copy in the commands that I want. I have to give from that /var/chroot everything that is going to be executable or used by those processes down in that root jail has to be in there. So there's that. Think about a time when you did that in the lab or less, and then what directories are needed, what executables did you give a jailed process. And then I say, what are the special files and why must they be there? Try removing them and seeing what breaks. Your SSH won't work without the dev random and dev view random. It won't work. YouTube, you said on a high level, can you maybe one time explain how a user flows from the internet through a jail to its distinction, just so I know I got it right? Yeah, I mean, we're going to do the Bastion process here in a second so you guys can see it. Hold on, I got to turn this back on. My lighting is just, can't get my stupid lighting right. Every time I switch like the colors of the screen, it affects my lighting. All right, so let's go look at the second lab. So this is a lab, I actually built this lab yesterday for you guys. So this is a brand new lab from yesterday. And I will link it to you guys here in a second. It's also right down there in with the other things. Yeah, let's go look at the full. So this is the full process here. So here's the new, what did I just do? Oh God, I linked the wrong one. Sorry guys. That's the other part of the lab. That's it. That's the other one. Sorry. Here's the Bastion host. That's from the challenge. All right. That's the challenge. All right. So let's pull this up here. Boom. Boom. And now we're going to do the Bastion part. And when you're doing this, I want you to think, could I write out the high-level steps of building a Bastion host? What would they be? When you jump into the Bastion host, do you have any other option than the one that you've given yourself? And the answer, that's going to be a hard no. And did you test that you couldn't leave the jailed environment? Yes. All right. By the way, guys, I always, when I get a picture like this, I right-click and I open it in a new tab in Chrome. And now I've got the picture I can look at whenever I want. Mirage, you said, how does the command work internally? Does it use a namespace? No, so chroot just uses, it changes the root of the system to be there. I'm actually not sure the facility. I've never really dug in on how that facility works, but I don't think it's using like the mount namespace or anything like that. The namespaces are separate from how chroot works. I've always just thought of it as like a file system isolation. I don't know that I've ever really dug in on what's happening under the hood, but that's actually something I have down here with like the digging deeper section. Well, in the other part where I say go read more about how these are working and how you might use them. So I just know the way that I do it, guys. I've done this, by the way. I haven't mentioned this yet today. I build these for the government, and I've built these on many government systems over the years, right? I started doing it with NOAA a few years back, and I've been doing it like since they lend me out from my company to other companies or to other government projects to build these. So your team is planning on building a Bastion system. You want to test the functionality. You've already tested the functionality of a jail. That's the other lab. Now you guys are going to simulate an air gap system via this connection. So it's going to be control plane to node 01, and then we're going to pretend to go into a third system. But since we only have two systems, we're going to jump back into control plane. All right, just so you guys all know. Typically, we'd probably be using the same user, but it doesn't really matter here. In the home lab system, you guys do this process, but when you jump in, you come in as like Streamer 1 or MC Hammer, and when you make that final jump, you become the root user via a key, and that's going to be something that we don't do here, but I can explain to you guys. I've shown you guys in the Discord how that kind of works, but let's build a simple jail. Let's build a Bastion out of it, and then we can play with it all the ways we want to. So build a jail on node 01 at var chroot. Okay. It's going to be the same process as we just did, but we're going to do it over on node 01. We've got control plane here, so we're going to SSH over. Add the basic framework to the jail so that you can populate it with functionality. We can do that. And then change to that and verify that we have the functionality. So we're going to do everything quick. We're going to go to node 01. We're going to make dir var chroot. Again, chroot. I don't care how you say it. Other people might care, but it really doesn't matter because again, it's a made-up word. So you copy. It's not like it came from like a Greek root or something, and there's a hard way to actually say it. It's a made-up word, so we can say however we want. Make dir is going to be the files the directory paths that you need, and then you can look at them if you want. And then I say, what directories do you see? And we're going to copy in bin bash. And we're going to copy in our packages. Again, we'll see that one error, but that error is not that big of a deal because it's this one up top here, which is already there. It's like a standard. So we're only copying in these ones, and you can go validate that if you want. So now I'm going to say, okay, I'm going to copy in the NS switch and the group and the passwd and the host and all those things that I need. And those are going to go down into Etsy, right? Hey, how's it going, Tani? So then we come down.
Was doing hard crew time when he asked for his one phone call. The warden slid him /dev/null. Rumors echoed through the namespace lockdown. Pig 99 swore he was innocent. Tell it to the sitcom judge. The Colonel Guard growled. X4, chair of the parole board, rattled the bars. Any last mounds? A lean container flexed, tossing cap _ drop weights to stay trim. Night fell, but escape was futile. The group walls were hierarchical and closing in.
All right. So, that's a pretty good one. Let's go back over here. We'll finish this up. Again, think of these questions as you're doing your challenge, right? That's what the labs are for, is to get you guys thinking about this. So, we're good on that. Copy in those to Etsy down in there. And we're going to copy in bash curl SSH. We're going to check the bash again, and then we'll copy in the libraries that are needed for bin SSH and bin curl. All right, there you go. How's it going, Tani? We are building bastions, and then we're just recording this for the Unit 4 system, or the Unit 4 of the security engineering course. So basically, we do the course on Saturday night, and then I come on and record it for you guys, and I drop it in a little playlist so people have it. If you're going to if you're going to be in the business of jailing users and processes, you've got to give them a trash bucket, dev null, or poop bucket, whatever you want to call it. You got to give them a little window so that they can log in and do stuff. You got to give them entropy because their stuff won't work properly. Like any cryptography stuff won't work without dev random and dev urandom. Dev 0 is needed for I actually don't. I mean, DD obviously needs it if you're going to use Dev Zero, but I can't think of a process right off that needs Dev Zero. But I'll tell you, if you start leaving these out and putting other things in, you'll start to see what problems happen, and that's kind of a fun little thing with jails when you start building them. Leave these out and then go try to run your programs, and you're like, I got the program, I got the link library, but you didn't give it Dev Null, right? And breaks. You didn't give if you don't give SSH Dev Random and Dev Urandom, SSH will not work. So it's like these interesting things that, again, like I said, you guys jump in systems all the time now and all the things work because everything's there. But we never really think about all the components that are needed to run a process, right? So jails will make you better at that. Trust me, because you're going to find all these broken things. We're going to copy in all this NSS stuff that we need for the communication to occur on the network. So yeah, zero's got to come from somewhere. So now we've done all that. We're going to exit node 01. We should be happy with that. The checks to make sure that you built that over there, so that's good. And it says you've set up a jail. It's time to put together the Bastion portion. So we're going to create a node user on node 01 called jailed user. We're going to create a user on control plane called free user. We're going to create a cool little Bastion script to lock in the actions of the jailed user when he drops in a shell. And we're going to configure SSHD to jail the user as they come in. These are the simple steps, right? So we'll user add free user here, and we'll do a pass WD, and I'm going to give him the password of 1234 because I'm quite lazy. 1234. I hope I did that right. And then we're going to go to node 01, and we're going to make jailed user, and we're going to give him a password of 1234 and 1234. And then now we're going to jail the user's SSH session. So we're going to VI SSH. We're going to hit Shift G to go to the bottom and hit O. And we're going to copy these two lines in right here, which says when you come in and when you're the jailed user, you automatically drop down into var chroot. So we drop you in the little jail. All right, escape : WQ. If you're going to be changing things inside the SSH daemon, you have to restart it. So we've restarted the config, and now that should work. And now we're going to go make a little Bastion script. And this Bastion script is going to be a fun little while loop. It's going to be a read and then a case. But let's look at it here. So we're in bin bash. We're going to say input a number. And read, you're going to give dash N2. I forget what that does, but the dash T is the 20 seconds. And then dash P is what you're waiting for. I forget what the N2 does. One of you guys could probably tell me. But then it's going to be either connect to a control plane as free user or exit. And if you wait the 20 seconds, that's another condition. So there's 4 things that can happen here. You can either push a 1. You can do a 2. So these 2 things can then actively happen. You can start to say anything else, and you'll be down here, and you'll get kicked out. Or you could wait 20 seconds. So those are 4 conditional cases that we can test in this lab of things that can happen inside of this Bastion. All right, escape : WQ, and come down here, and we're going to copy it and make sure it's executable in var chroot bin bastion.sh. Oh, it only reads the 2 characters. Yeah, I knew it was something. I just forgot what it was. So we can force it, to not read more than 2 characters. That's actually good. Gives them less options before it kicks you out. Now we're going to go look in the etc pass WD, hit Shift G to go to the bottom. And for jailed user, we're going to change his bin sh to bin bastion.sh. So now he's forced to use that Bastion script. And then we're going to copy that in over the etc pass WD we have down in the jail. Now we're going to exit. So we've set up the jail. We set up the jail already. Now we're setting up the Bastion for when the user comes in, they're getting locked in the jail, and we're forcing them into this Bastion script instead of a normal shell. They don't have a bash shell. They have this. All right. So let's go do it. Let's go check it, right? We can sit around and talk all day about it, but one test is worth 1,000 expert opinions. We'll just sit here and type it and make it work. It's time to test your Bastion. Connect over. Verify that you can only do the things that you think you're supposed to be able to do. That's the functionality or lack thereof. And then finish the connection back to the control plane as free user. So, check host name. I'm on control plane. I'm going to jump over to node 01, and I'm going to put in the password 1234. And I'm going to test my four cases. So the first case that I want to test is, does 20 seconds pass and kick me out? So I'm just going to keep my hands up here so you guys see that I'm not touching my keyboard. By the way, that 20 seconds has to coincide with the number of seconds you gave in the timeout. So let's sit here for a second. I'm not touching the screen. That's a long 20 seconds. Kicked me out. Okay, I expected that. So I'm going to go back in. And I'm going to try 2 for exit. And it kicked me out because I said exit. And then I'm going to try again. And I'm going to try another use case, which is I'm going to type ASS. I tried to type ASS, but it didn't work. It kicked me out. Okay. I'm going to try again. And this time, I'm going to type 1, the correct answer, and it's going to ask me for a key, yes. And then free user is also 1, 2, 3, 4. And am I back over on this system? Have I established from here jailed user as the jail? I was jailed in the Bastion, and then I jumped over here, and now I'm in an unjailed user doing whatever I want. Yeah. Do all those things. And when I exit, it zippers me all the way back out. I don't stop in node 01. I get kicked all the way out back to root on the original system. So when I exit this shell, I don't stay here. I get all the way back to the system outside. And some of you guys that have worked in the home lab, you know when you leave that home lab, you don't stop in my system again. You go all the way out. You get kicked out the door every time. So come down here, test functionality, sitting idle, do all those things, hit finish to check the lab. So that's the lab. So to review, in the lab, we built a jail. We enumerate the steps. We understand what we're doing. We don't just hit the buttons and do the lab. But the lab should work for you. Then you come down, you build the Bastion, and you test that out. And then I have a little bit of a challenge. If you fix the drawing, you can go do a poll against my GitHub. You do a pull request, and you can fix that drawing. Because when I first made this, this was jailed user and unjailed user, but I named him free user. So if you want to go draw that in again in Excalidraw for fun, and then get that and then upload it, that's down here in, if you go to my, here, you can go to like Prolog Labs, and then you drop in here, and it's under Linux Labs, and then where we were at, which is 210, building a Bastion. So you can actually go change that Bastion if you want to. You guys can update that picture if you wanted. And that's my digging deeper challenge for people who want to spend a little time. And I said do a pull request and get some GitHub street cred or something. I don't know. I don't know any of that stuff because I'm a Linux engineer. I'm not a software guy. I don't know what it gets you in the world, but you can at least go do that if you wanted. All right. So if you were doing the lab with it, if you were doing the actual course with us, right? If you were working through it, the deliverables for this week would be, and you know what, I feel like when we first did it, it was just the worksheets, and I'm okay with you guys just doing the worksheets, I guess, but you would go through, you would do the discussion questions on the Discord, right? Discussion questions are up. You could talk to people about bastions and air gapping systems. You would go and figure out some of this definition and terminology, and then you would do the lab assignment, which is the lab here. And then there's a bunch of, I did a bunch of digging deeper this week. This is stuff for you to go work on if you want to. But while it isn't strictly speaking an automation course, you can go look at the way that I deploy bastions out of my GitHub. And that's actually the way that we run them for the labs here that you guys hop into. What would you do to make it better, right? How would you improve it? Come down here, find a blog or GitHub where someone else deploys a bastion, compare it to our process. You won't find much about bastions out in the world. There's not a lot of people who show how this kind of stuff works or work on this stuff. I said, knowing what you know about bastions, jails, and air gap systems, now reflect on the first 3 weeks. So if you were doing the rest of the course, all the STIGs you reviewed and touched, do any of them seem moot or less necessary now that you're in an air gapped environment? Why or why not? And I said, to answer your question, if you read about zero trust, which is really like a big thing in the industry right now, how does that change your answer? Because I'm going to tell you, a zero trust purist is going to tell you, it doesn't matter if you're air gapped. You still have to be zero trust everywhere. And some people would say, you know, but the older model of having a big outer bastion wall is, I don't want to say it's a disproved model. It's just, it's not as secure as the zero trust model. Zero trust typically means that at the lowest level for most of you guys, you're only talking through certs. You're only talking, a system downloads the public version of a cert to talk to the right system, and it can only deploy it and run it if it's got permissions to, and only those two things will ever talk, right? It's how Kubernetes works by default, right? Everything's certificates underneath your kubelet, and your kubectl is using certificates to talk up. Oh, speaking of that, I got to get our web page back up. The wife took my whole network down last night while we were doing our first Linux course, and then the wife was in there unplugging stuff in my office. And I've moved offices, so I wasn't in there to stop her. So everything got unplugged last night. That was fun. While we were doing Linux, it was fun. All my servers went down. So think of a Linux system where you would like to deploy a Bastion. If you cannot think of one, use our Prolog lab. Some of you guys have seen those diagrams. Draw out how you think the system works, right? Then reflection questions. Does it matter if a user knows that they are jailed? Why or why not? That's an interesting... I almost want to call that a philosophical question, but it is important. Does it matter if the user knows that they're jailed? Should it change anything? Should it change any way of the process of how they log in and all that kind of stuff? All right. Okay. So there's that, and that is the whole course. If you got questions, go hit me up on the Discord or let me know. I'm gonna stop the stream here because I just want these recordings to be specific to the course. But again, hop up in our Discord. Here's all the discussions. You can go see what other people. Nope, you guys should be able to hear me. Okay, sorry about that. So, yeah, I was, kind of just going and doing some labs and showing you guys some stuff that we've already worked through and doing that. I wasn't going to spend a whole lot of time tonight actually streaming because I've been working on other stuff. But the two things we did tonight were bastions and air gaps. And then we started with the one before, well, the one that was after it, which was updating the systems and patch cycles. So if you guys were to watch this VOD or watch it over on YouTube later, that's what we were doing. Okay, so I'm gonna raid over. I know we just got a raid over on Twitch, but we're gonna raid over to a cybersecurity guy that does pen testing. So we're gonna go and hit up BlazeBits. For you guys on YouTube, I don't have anything cool for you, so I'll just tell you I will see you guys